Well, hello and welcome to SkyTour LiveStream. This is me, Mark D'Antonio, and I am here on Halloween in October 31st. And I have with me someone who is very far from being like a witch or anything like that, but she's also quite clever in her own right. It's Carol Carl. Hello, Carol.
Well, hello, Mark. Thank you for very much, having me here. Oh, that's my real voice. I try to disguise it with this one,
I
but
can't
yeah.
believe she did
Oh,
that.
but yeah, Halloween. Who'd have thunk it?
I know, and guess what? It's a full moon on Halloween.
Could anything be better?
It's a pretty
Oh,
crazy.
that's good. That's nice. That
Scare
wasn't
everybody.
Dingo, right?
No, unfortunately, that was my attempt. Yes, and tonight is really cool. There's a couple of things in the sky that we're gonna look at tonight. And I'll tell you, hey Maddie and Anahara and Dapple Ben and Daisy and Zoe and Tim F and Terry Groff. Boo! Oh, you scared me. And PG, what's up, brother? Nice to see you guys here. It is Halloween night, but we're gonna still have some fun tonight. It is a full moon. The full moon is out. It is up, and there's all kinds of weird creatures running around on my front lawn. So I don't want to go out if I don't have to, but I know I'll have to go out a couple times. A couple of them had these red eyes, but I forget whatever. Maybe it was not real, but I don't know.
Wow.
But yeah, it's pretty cool. And so, as I said before, Carol Carl is with me tonight. Behind the Obsidian Curtain, Friday nights at 7 p.m. still.
Still, indeed. Yep,
Okay.
indeed.
I know you did a
alive
show,
and thriving.
You did a 6 p.m. show the other day, and
Yeah,
what was that about?
well, when I had those wonderful ladies from, the chicks, I get to call them chicks and they
UFO
vetted that,
chicks.
from Phoenix MUFON, Marianne and Tara and Stacy Wright. Yeah, and that was pretty darn, and you joined us, so you were there.
Well, I came in, but I didn't want to come in like right away. I wanted to listen to them too, because they are fascinating people, all three.
Oh, they are indeed. Yeah. We had a blast. And that's sometimes, every once in a while, my Mr. Producer Man, Bill Skywatcher, fixes it so I can take advantage of that empty open hour before my regular slot and do a 2-hour special.
That was really cool. That was really cool.
Yeah.
And we have a 2-hour show for Sunday night. We're planning a live show. It'll be from 8 to 10 on kgraradio.com, which is where Carol's show, Friday nights at 7 p.m. on kgraradio.com, will also air. And we reach a lot of people. Each month. And behind the Obsidian Curtain, SkyTour Radio, and this SkyTour LiveStream, we reach a lot. And for those of you who've just joined us, I want to say one of the things that is really pretty exciting right now, for the 16 of you listening and watching right now, and there'll be more, but I have to say, SkyTour LiveStream West is complete. The observatory's roof rolls off and on. The building is finished. It's metal sided, and we will be shipping out the equipment, including the very telescope you see here that we're using. We're going to be shipping this out, and behind me is another telescope to put here. And we're going to change the telescope here to a more of a research instrument. And then the telescope in the desert is going to be used for these just breathtaking views we've come to appreciate. And the size of the interior of that observatory is going to allow us to put 3 telescopes in there. The one is going to be SkyTour LiveStream West. The second is going to be another streaming group that says they want to. And if they commit, I will tell you who they are. And then the third is going to be reserved for a SkyTour LiveStream second instrument that we obtain and put in there. That'd be a third instrument, actually. We're looking to do some very nice wide-angle views of the sky, and the third instrument, under a very dark sky, will just produce the most astonishing views. So we're looking at that as well. All right.
That is spectacular. And in chat, Maddie says, awesome. Tara says, woohoo. And Daisy and Zoe Amethyst say, yay. So say we all.
Yeah. And we all will say, I hope. I do have to publicly thank Tara. Tara, she's a pit bull. You know,
I
she
love
she
it.
took on the job of overseeing the construction out there with Marianne, and they, I have to say, Tara was there, and what I got out of this, what I got for an observatory out of this, I couldn't go. Okay.
Yeah.
I mean, I was planning on going from the 5th of November to the 12th to actually do the build that
Yeah.
already occurred. Now, why did we do it sooner? Because I realized in November I have to film a 2-hour pilot for a TV series, and I
Yep.
am not going to be available. I have to film almost the whole, no, 3/4 of the month of November is going to be filming, so I won't be able to be out there. So I had to actually cancel the trip for that reason. It wasn't because of COVID this time.
Mhm.
So I currently have it scheduled that I will be out there on the 30th of November to the 13th of December. So all this equipment's getting shipped out between now and then, and it's going to be put in place and up and running by the time I leave. So SkyTour LiveStream West will be live in early December.
Spectacular. Shall I say stellar?
You may. Interstellar.
Yes, all right, well, Interstellar indeed, and yeah, and not the movie, because this ain't fiction. Oh, we are so thrilled for you.
No, I'm taking everybody with me because, you know, I'm doing this. Yes, I love telescopes with good views, sure, but you know what I like more? I like hearing your comments. I like hearing what you have to say. See, we look here. This is the Dumbbell Nebula. We've looked at the Dumbbell Nebula a number of times. What is a dumbbell? This is actually a star that has died and left behind this cloud of gas and dust around it, and all of that was part of the star's main envelope originally, and it's actually sloughed off these layers on the outside, and then it ended up leaving this debris in space. It's slowly expanding, and eventually it's going to expand out beyond the size of this entire picture and out further into interstellar space until it gets slowed down by other stuff in space where it'll stop, right? But as it's moving out at a what space would consider a high rate of speed, it collides with other material. When it does, it causes shock. When they're called shock fronts, they actually impacts and pushes the stuff along like a snowplow, and that compresses the stuff. And sometimes, in the absence of any other gravity, that's all it needs to start a local area of condensing cloud, which might then become a star or a star system with the star and its planets. This is something that we are looking for. We're looking to see that happen. See? So I want to say also to Terry, I see that December 4th is your birthday. Well, brother, I can tell you this. That only gives me a few days to get this up and running. But I'll try. I'll try to have it live on your birthday. Nice thing is, 300 clear nights a year, I'm going to be tired.
Tired but fulfilled.
Oh, yes. I will be changing my schedule, too, so that I am more of a nighttime into morning type person, just so that I can take full advantage of this for all of you to make sure that I can bring you the best interstellar scenery. Is that a good way to put it?
Oh, yeah.
I'll give you the interstellar lowdown, the interstellar scenery. So, yeah. So, incidentally, just to remind you, this little tiny white spot right there, that's a white dwarf. That's actually about 40,000 Kelvin, okay, which is many more tens of thousands of degrees Fahrenheit. And that is a highly compressed star with the remains of the star that's collapsed down to this tiny little object the size of the Earth. That's what the white dwarf is. And it's so hot, and it has such intense ultraviolet radiation that it causes the atoms in this cloud of former stellar mass that used to be the star's envelope to glow. That's really interesting. And that blue color is characteristic of oxygen. Okay, doubly ionized oxygen, we call it oxygen 3. That's O with a 3, like a Roman numeral 3. And it's that because O1 is the base state of oxygen, where it's just oxygen and has all its electrons, has all its protons, of course. And so, but when it ionizes and it loses an electron, it becomes an ionized atom, and then it goes from O1 to O2. Ionize it again, and it becomes this O3 we're talking about. And those electrons end up recombining. They get pushed off by the ultraviolet energy from this white dwarf right there, and then in collisions and being off the atom, they end up losing some energy. They fall back down into the atom, and as they do, they give off light. When the electrons give off light in oxygen atoms, that light tends to be mostly blue, like you see here. And for the eagle eyes out there, you'll see there's some red here too. So there's a little bit red up in here and a little higher up there. And there's some up above here. This red up here, okay, this stuff here is it's hydrogen gas, which is mostly what stars are made of, and it's also neon, which is another element that's found in these envelopes of some of these stars. And stars of this type, this size, can't make those materials themselves. Okay, so what that shows us is that they're making other elements in their cores, but they can't make these other elements that are heavier. So what they do is, when the star was first made, it was made by the debris of all the other stars that made the interstellar medium from which it formed. So the star was formed with all this stuff in it, all these other elements. Okay, the sun has elements in its spectrum that it can't possibly make because they're way too heavy, they're too big. Okay, so that said, that means that a lot of the stars already have a lot of these elements in them. They were made with them. Now, they make additional ones in their cores, and when they blow up, say in a supernova, then they make other elements. But stars like this one can't blow up in a supernova. Stars like ours cannot become a supernova. They slowly expand as they start running out of their fuel. They expand, okay, and the outside layers get away from the star and kind of slough off, and this is what you get. This hazy debris here that we see right here. Okay, and sometimes they go in certain directions over others, and so in other words, this could just be a sphere, but it's not. It looks like an hourglass. Now, maybe that means is that this star, okay, was actually doing something a little different. It's possible that this star was rotating like this, okay, rotating rapidly like this, and so most of the stuff went off like that, right? And very little potentially went off the north and south poles, but maybe went off to the east and west directions of the way the star was rotating. And these nebulae are called bipolar nebulae, even though we don't know if they're poorly behaved or have difficulty socially. But that's what, in terms of nebula, that's what bipolar means. They actually have two poles. One has a dominant matter at the top or bottom, and then it's anybody's guess as to how that formed. There's some ideas, but we don't know. So this is the Dumbbell Nebula, Messier 27, in the constellation of Vulpecula. Okay, and Vulpecula is a very interesting constellation. Let me check something here for 1 second. Okay. Hey there, Isabella. Isabella is here. Isabella Melamed, how are you? James Dugan is here. Nice to see you. And Carol Carl, are you here? Yes, of course you are.
I'm here as far as I can tell. Terry Groff, of course. Well, we already knew he was here. And James Dugan.
Yep. Yep. James has joined us from down under. He's from Australia. Our buddy down there. The southern sky is something I have never seen. So I can tell you, if I get a chance to go, yeah, I'm gonna probably end up staying a while. I want to be able to see all that.
Yeah, and you have to see Alice Springs.
Alice Springs, yes, and I'm going to see Siding Spring Observatory.
Oh yeah.
Mm-hmm.
It's so funny. I'm just remembering I had a dream last night that I was walking through this dark street barefoot, right? And there was some sort of lighting that was reflected on this wet pavement. And I looked, and to my right, there was this creature about 4 feet tall jumping around, and it was a wallaby. And I thought, oh, well, I guess I know where I am.
That's funny.
Apropos of nothing, but yeah. So, yeah,
that
James.
Is so cool.
A wallaby.
Yeah, a wallaby as opposed to a kangaroo.
Yes.
They're different.
Yeah. And T is here. T is saying, what is the blue moon?
The blue moon is when you have a second full moon in 1 month. And that's what's happening now, if I believe.
Yes.
Yes, James, I will be checking it out after COVID and so forth. I do want to get down there. There's a couple of Australian MUFON groups, actually, that have been talking to me about possibly coming down there. And I would actually love to give a talk down there. If I went down to Australia, I would give talks all over the country if I could until, just because. It's, you don't get a chance,
Yeah.
Mm-hmm. And by the way...
Till they hauled you away, you would be given talks.
That's exactly right.
Get that guy out of here. Right?
That's right. I want to say hi to Cypher, too. Hello there, Cypher. What's going on? And I have to say, once again, happy Halloween and welcome, T, by the way. If you guys, for those that haven't seen it before, this is the full screen that we typically use. Over here on the left side here, right above my head, that's our telescope control system over there. This is me down here. Hi, hello, down here, lower left, okay. And then over here, okay, on this side, this is our observatory peekaboo view. This is the infrared view into the telescope there in the dome. This is our camera control cluster where our camera is controlled from. So everything else that you'll see on the screen, they will come and go depending on whether I pull them up or put them away. We also have another view, which is a very good thing, and I'll show you that in a sec. First, I get rid of that. Okay, and then I bring up this. This is our planetarium view. This is also how we control the telescope. This is hooked into the telescope, so we can actually move the telescope with this. So right now, for instance, we're on the Dumbbell Nebula right here. Okay, and there's another place we're going to go. Right now, I'm going to go here.
And Greggy Gilkin says, if you come to Australia, don't forget Adelaide, please.
Oh, Adelaide's a beautiful place. Beautiful place. Courtesy of Google Earth, I have been all over Australia.
Wow. Yep. I've seen much of it myself. Isn't that an amazing process?
Yeah. I've been to Uluru, a lot, and that's Ayers Rock,
Yes, that's what I thought. Yeah. Yep. Fabulous looking place.
Yeah, Uluru, and I love it. Okay, now we're moving the telescope, so I told it to go to this spot. So what happens is the telescope is going to find a bright star, and it's going to center that bright star that it knows, and then from there, it knows exactly where to go to get to this little magical place that I'm looking at. All right, so the first thing that happens is we're come in and it's gonna bring us to this star. This star is 52 Cygni. If I've got it right, let's make sure it's right before I go spouting off here. But it typically is. The telescope is pretty robust, but sometimes it has failures. I haven't used the telescope in a couple of weeks because of the fact that it's been rainy.
Yeah.
Right? So here's what I'm going to do. Okay, let's bring up our telescope control up there. And I'm going to take us a little to the west. Okay. I'm going to take us a little to the south. Okay. And then I'm going to wait 11 seconds. Exactly 11 seconds. Why? Because that's how long it takes for the telescope to lock onto a guide star. Because it's self-guiding. It has a self-guider on it. All right. And then we'll do a 25-second exposure at 25,600. And what does that mean? Well, over there on this right side, if you look over there, not over here, look over there, okay, you'll see where I'm showing you. This is our exposure time here. Okay, that's our little logo, STLS. This is our sensitivity, or ISO speed. That tells us how fast we want the camera to take the picture, basically. All right, so we're going to do 25 seconds at 25,600. This is a discovery shot to make sure that we are where we belong. Oh yeah, the red roos are tall. And they don't they kill people each year too, James? I mean, if you get in a fight with one, you're gonna lose.
Wow.
Unless you have
So
a
the old myth
weapon.
of the boxing kangaroo, right?
Oh, they have sharp claws too, if I recall.
Ouch.
Well, James will tell you. All right, let's see where we are here. Yeah, I can see it. We just got with the moon. It's hard, but it's right there. Okay,
Yeah.
I will do my best to make that a little clearer. I do have another way to do it. Casey, we have the bright full moon out, and the fact that we can still take photos of faint nebulae. You see that faint nebula right there?
Oh yeah.
The fact that we can still take photos is really testament to the fact that the equipment is just that good. That's just astonishing. And there's a reason why we're taking this picture, and I'm going to take the star and move it out of the view so we can see the southern part of this a little better. There it goes, it's gone. All right, and what we're going to do next is to take a little bit longer exposure. No, I'll keep 25 seconds. Again, just I'll show you why in a second. Now, the thing I didn't tell you about was that when we actually look at where we are in the sky, this area down here, right there, right above my head. Okay, you see how it says narrowband 2. This is a filter wheel that we're connected to right here. I have a filter wheel. It has 5 different round holes, and in each of those holes, I have a different filter to give us different information. The one we have now is a narrowband filter. In other words, if this between my hands represents the entire spectrum that we see coming from the sun: red, orange, yellow, green, blue, indigo, and violet. This spectrum is a broadband spectrum. We want to take slices of very important areas within the spectrum, and only that. Things, for instance, like that greenish glow we saw from the Dumbbell Nebula earlier. That's a specific location in a specific place in the spectrum. So if we have a filter that takes just that slice, we'll see that. Okay? This filter does that. And this particular filter is slightly wide in its selection process. So it has a slightly wider set of slots that it takes out of the spectrum. But the other one I have a narrowband filter that's actually very, very thin slices through the spectrum. And you can take pictures right next to the full moon and see nebulas. But because it's such a thin slice, you have to take longer exposures. And sometimes those exposures have to be 1, 2, 3, 4, 5 minutes. But the results are astonishing. Maybe we'll take a couple of those tonight, but we'll see. So right now, at 25,625 seconds, we're going to do this other shot. And, okay, 52 Cygni is out of shot up there. And we're looking down below, and the object we'll see is one that has a specific relationship to this holiday.
Aha.
And we'll see what that is.
Yeah.
Okay, so I mean, it's with the moon, it's a little hard, but you can see it right here. Can you see this wispy structure here?
Right.
Okay, this wispy structure, guys, this is actually a very interesting structure. Look at all the stars. I mean, isn't it stunning? Even without, I just think it's really cool. Yeah. Anyway, that wispy structure that you see right there has a little pet name out there, and it's called the Witch's Broom. Happy Halloween. This is your Halloween nebula. The Witch's Broom. So that's kind of cool. And
It is.
Yeah. And so what I'll do now is I will take another shot. But before I do that, I am going to show you that I'm going to take this with our other filter. So I'm going to come up right up here, and I'm going to hit that arrow right there. Click. Okay. And the wheel rotates, and now we're on narrowband 1. You can see it says narrowband 1 right up there. Okay. And narrowband 1 is the filter we're going to use now. And so when we go to do that, all we do is say, let's go to 30 seconds at 25,600. Now let's go to 32,000 ISO. This camera's pretty fast. This camera can take us to 409,000 ISO. If you have the camera in your hands with a lens, you can walk around in pitch blackness and see it in daylight brightness with full color. That's how good this camera is. All right, and that's what we're using to do all this for you guys.
Wow.
Yeah. Hey, Gina Leone. Welcome. Marco, what's going on? I've always said, I make it a point, if you take the time to come here, then I take the time to say hi to you. And if I don't, it's because I just haven't seen you. I just didn't see it. But if you make the effort, well then, by gosh, I better make the effort. Because, I just want you to feel good about it. Also, just a little something. I have managed to make the... see, now you can see it better, see?
Oh, right.
See, that's how this filter works. This filter, look at that. There's your witch's broom. Look at the detail. Isn't that gorgeous?
There it is.
It is beautiful. Oh, yeah. So that's the witch's broom, and what I'll do is I'm going to just take us and bring 52 Cygni back into the view just a little bit.
Meanwhile, Marianne Robb has entered the house.
Marianne who? Hey, Marianne.
I think Rob with 2 B's.
Yeah. Hey there, Marianne. Marianne, do you have your Skype available? I'll bring you in with us if you'd like to come in and say hello.
Oh, cool.
Because you were on Carol's show. Now you're a superstar, and you can tell us all about your show coming up with Chris DiPerno on KGRAradio.com.
Oh, sweet!
I'd like you to tell everybody about that. So I know I'm ambushing you with this. Oh, there you go.
She's hanging out with Alejandro and Karen.
That's okay.
Very cool.
You can get on, then Alejandro and Karen can say hello to everybody. So let me know.
Alejandro Rojas, and what's Karen's last name?
Karen Brard.
Karen Brard, right.
Yeah. Karen Brard and Alejandro. Karen Brard, as you know, is the owner of the UFO Congress. And they just had their successful UFO Congress virtual event. And it went very well. So
it did, yes, indeed.
I would like to make sure that people understand how well it went. So I'd like to have them... Marianne, if you can come on. Yeah, good. Say you can try. Good. Well, try harder. You're not trying hard enough. Come on. Move it. Let's go.
Make it so.
Make it so, number one. Look at that. There's the witch's broom, guys, right there.
Oh, my.
Now, remember that thing I told you? The gas expanding, it collides with other gas, and it starts to bunch them up like a snowplow, and it causes what's called a shock front. Well, look at what's happening right here. There's a shock front right there. That's an example of what I'm talking about. This gas is expanding outward. Let me get over there. This gas is expanding outward. As it expands outward, it's compressing other gas ahead of it. Other gas that's being pushed out by this nebula. Yes, I can invite you. I can actually just set you up, Marianne, and basically call you when I know you're ready. You're in Skype, aren't you? Oh, maybe she's not in Skype. I better find out. Anyway, and when that compresses up against her, then you actually see areas where this stuff gets so dense that it begins to form a very dense tendril of gas. That's just what we're seeing here. Okay? All right, let's see here. I'm going to, let me figure out how to do here. Okay. Oh yeah, you're in here, Marianne. Let me see. Stop that. Oh, wouldn't you know it? She's calling me. You can't call me, Marianne. You gotta call you. Yeah. So I have to add her. Yeah, no, I have to add her. Okay, so let's do that. Let's go back. Okay. I was trying to find her without disrupting. Okay, we're gonna go and add, and let's see here. Where is she? I have to search. There we go.
Yeah, there she is.
Okay. Okay. You've been added, Marianne. So she should be able to come in. Where's my chat? There we go.
Trick or treat, Marianne.
Well, I added her, so if she can figure it out, she can join. So yeah, this is the beautiful witch's broom. Look at that. How stunning is that? You know?
Quite. And so appropriate.
Yeah, it is.
Marianne is saying all caps, do it. Do you have to do something else at your end? I don't know.
I did already do it. I said.
Yeah.
I basically added her to the conversation, and she has not yet responded. This is the one that's on. Okay, here we go.
And meanwhile, Laura Newbert says, Happy Halloween. Happy
Halloween, Laura. Nice
tonight,
to hear from you.
Yeah.
Marianne's being called right now.
Okay.
Oh, okay.
There she be.
I heard you a little bit, but then you went away.
Okay.
There you go. Hello.
Am I still there? Hi there.
Yeah, there you
Hi
are.
there.
Alejandro kept saying I needed to be. It took me a few minutes before the accept button came up, so that's what took me so long. So sorry about that.
Okay, sure it did.
Yeah. Likely story,
Yes.
Officer Rob. Yeah, there she is. I just saw a brief
Yeah.
visual. There you go. All right.
Yeah, she turned off her camera, which is good because, we don't want the to overload the bandwidth anyway.
Good point.
Yeah. So Marianne, you still there?
I'm still here.
Oh,
Can
okay.
you hear me?
Yeah,
Maybe you should go off camera.
that's fine. Turn. Okay, there you go. Well, you know what? I want you to tell everybody. No one can see you because only we see you because we're the ones in Skype. But if you could tell everybody all about your show coming up and tell us when it's going to be on KGRA and the whole 9 yards.
Well, it's called I Detective. And since it's going to be coming on here this coming Thursday, which is November 5th,
Awesome.
at 6 p.m. Eastern, it's really a cool show. It's going to be all about cops, for cops, with cops, or however Christopher says it.
For the public.
Is going to be, he's the host. We've got a gentleman by the name of Ray Dietrich, who is going to be doing the news for us. He's retired, I believe it's LA County,
Okay.
California officer. A gentleman by the name of John Savage is retired Syracuse police officer, along with Chris DiPerno, and who's also retired. But we are going to do interviews with ex-police officers, or possibly maybe attorneys, or anybody like that in law enforcement. So it's all going to be law enforcement stuff.
Wow.
Okay.
There's Karen over there.
Interviews about paranormal or UFO or just police stuff?
No, all police stuff.
Okay.
It's all going to be police. We're going to start off with what we call roll call. If you guys know, and at least in Arizona, it's called briefing. I know back east, it's called roll call.
Yes, I'm familiar with your briefing.
Yes, you are.
3 a.m, guys. 3 a.m, okay?
Whoa, ouch.
She comes in. She's in her frickin' cop uniform. And she comes into in the room and says, "Okay, get up." I'm like, "What is this, drill sergeant?" I gotta get up and be ready to go to this briefing because I was gonna ride around with her all day in the cop car, and there I was, half bleary-eyed, and she's like bright-eyed, bushy-tailed, you know. It's like, jeez, you know.
Just tell him you were just scared, you know. But he wasn't in the back seat, so that's a good thing.
No, being in the back seat isn't a good idea at all.
Yeah, no.
The back seat of the car we had that day, you know, the seat's just solid hard plastic. You know, it conforms to your butt, but that's it. It's a solid hard plastic. It's like, man, I would not want to be in that back seat for any reason whatsoever. Because, you know, it's solid hard back seat plastic though, because they have to be able to disinfect it, you see.
Oh, right.
Yes.
Yeah. There's those times.
Yes.
So. Anyway, if anybody, or like I said, it's our first show, and we're going to be doing it live, and we are on this Thursday, because it's right after the elections and right after everything going on. We are going to have it's just going to be live, and we'll be able to tell what's going on in the west part of the country and what's going on in the east part of the country, because two are in New York, and Ray and I are in California and Arizona. So we'll be able to kind of just tell everybody what's going on, any riots, anything. So that's going to be cool. And then after that, we're just going to go into our normal routine on the radio show. But every week, Thursday nights at 6 p.m. Eastern.
What is the
what
normal
a cool
routine?
Concept.
Yeah.
I'm sorry, Mark. What did you say?
Well, what's the normal routine for that show?
Normal routine is we start with roll call, which means any news stories that are very interesting in law enforcement.
Okay.
And then we into our interview with our guest. And then we end with what we call choir practice.
What?
A lot of people, if you're not an old-time cop, you don't know what choir practice is. But choir practice is basically after work, get a beer, hang out with each other, and just have a good old time for like an hour or two.
I thought you were gonna like sing. I've heard some of those guys sing in the police department. It's not pretty.
Yeah, and you heard myself saying happy birthday at times. So yeah, it's not. It's anyway. But no, called choir practice.
Okay.
And it's going to be fun. But and when we end the show with that, and that's it. And it's an hour show, so it's going to be perfect.
Absolutely cool, but no singing. I'm remembering, you know, like I don't know, 20 years ago or something, there was a TV show. I don't know how it did, and I'm not sure I ever watched it. It was called, I think it was just called Cops, and it was sort of like a cops musical.
Bad boys, what you gonna do?
Yeah, well, no,
not that show.
I love that song. No, it wasn't that one. It was something else that really featured music.
There was one, Reno 911.
Yeah, that was funny. That was a comedy.
Yeah, the best, I would say, one of the best police shows that I've heard is Hill Street Blues back in the 80s.
Yeah.
Remember that?
Yeah.
I'm an idiot savant when it comes to that stuff. I remember all the songs.
Right. No, how about just plain genius memory kind of thing? Yeah. And strangely enough, if you remember Twin Peaks, the David Lynch show, written by David Lynch and Mark Frost. Mark Frost wrote tons of episodes for Hill Street Blues.
That's right.
Before he ever did Twin Peaks, yeah.
You're absolutely right. I remember that.
Yeah. Francis Palmer says hi from the UK, by the way.
Hi, Francis Palmer. Hello. I'm glad you're here. Happy Halloween to you. And for you, it's no ghosts or anything there, but it's 12:47 for you. Yeah. Yeah. Marianne, does
meanwhile, Gas Mask
Alejandro
is
want to
singing
come
99
on?
beers on the wall. Okay. Okay.
Marianne, does Alejandro or Karen want to come on and say hi?
They do, both Karen and Alejandro. And we've got Brian Bender standing here.
Oh, sweet.
Anyway, here comes Brian. I can't make the screen. If you can see, that's Brian Bender.
I can see his chin.
You can see his chin?
Yeah.
Wait a minute. Okay, wait a minute. Let's do that.
Oh, yeah, okay. Hey, Brian.
And then here comes Alejandro. Come here, Alejandro.
Yay. Hello.
So
there we go.
Hey, Alejandro. Good to see you, brother. What's happening?
Roswell, New Mexico shirt on.
Nice. Very good.
My Halloween spice flavor for the day.
Yeah.
Where's Karen?
She's probably putting something.
Ah.
So, you guys, what are you looking at? Have you seen any like ghosts or goblins or maybe witches on their broomsticks or anything?
Actually,
Well,
we
funny
are
you should
looking
mention that,
at-
Alejandro. Hi, this is Carol Carl, by the way.
Carol Carl's here with us,
Speaking of
yeah.
witches and brooms.
Yeah. You gotta tell them.
Well, we're looking at the witch's broom at the moment.
Yes.
You can see those little tendrily things. Is that showing up for you? That's the broom part. Am I right, Mark? That's the broom part and not
this
the
is
handle.
the witch's broom right there.
Yeah.
Yeah.
Wow.
Part of a supernova remnant. It's really cool.
Oh,
Yeah.
that's really cool.
Yeah, really neat. See there, it's all those little tendrils there. It's really cool. Wow. My favorite
Is the
place.
moon guys at all right now? Is it being the bright moon or not yet? Or
Well, you know, it's a full moon.
oh, it is of tonight.
Yeah.
Wow.
On Halloween.
Cool.
Yeah.
All right. Well, Karen kind of went somewhere. So we're gonna have to get her in a minute.
Gotta
Okay.
order dinner.
Oh yes.
Oh, you guys having dinner?
We're having dinner right now. I'm just
Wow.
eating salt and pepper. What kind of pistachios? They're delicious. Highly. They taste better than they sound.
Yeah.
Salt and pepper's good, but they actually have kind of a very spicy covering that's delicious.
Indeed they do, I'm sure. Very good.
I think you had some when you were here last.
I think I did.
Yeah.
I think
really
I
good.
did. Yeah.
What's the spice? Is it like red pepper or
I mean,
cilantro or?
it's kind of a red pepper,
Wow.
but with some salt. So it's got a little bit of spice. Marianne's a spice wuss. So I can taste them. They are pretty much no spice for me, but for her, they're a little hot.
Ah. Okay.
You're so funny. Thank you for that. You're over here.
Maybe there's some sort of joke about pepper spray we could make, but I don't know. I'll leave that.
Oh, I bet you there is. And Marianne would know all about it.
Hey, yeah. Well, there is. We got spray. We got to maybe spray. Let's see if we can get that in there. There we go. Put it up a little bit further. There we
Oh, I
go.
see.
Ha ha.
I see Karen behind you.
No, you don't.
She was hiding.
She's just a ghost.
Yes, there she is. There was
Hello.
an alien here. Yeah, I swear.
So that's nice. The four of you having dinner. That's awesome.
Oh, that's cool.
Pretty. Anyway, all right. Again, we got to go order dinner. I guess it's Greek food or something tonight.
Mm. Awesome.
Ooh. Yum.
So, all right, well, are you going to keep a Halloween theme? Say, I got the witch's broom. Is there anything else?
Mm.
We can look at?
Well, we looked at the Dumbbell Nebula, but that doesn't really sound like a Halloween-y thing. So, all right.
Is
Well,
there
thank
some
you.
skull thing? Something to do with a skull,
Well,
maybe? I don't know.
only unfortunately in the winter. We can't wait for the winter sky to come up
Ah.
tonight because it's been going for a while.
Right.
Well, guys, thank you for having me on. I think I'm going to skedaddle and get dinner, but
I'm sure you got a lot to do.
it is an honor. I'd love to come on your show when I'm just at home and can spend some more time.
I see Karen. Karen smiling. You guys can't see it. I tried to set up so you could see the video, but I couldn't get it to come up. Sorry about that.
Well, tell everybody, you've been telling everybody about your the observatory on how it's built. Have you gotten into that yet tonight?
I did. I made sure they understood that you and Tara were very important to the process.
Oh, well, thank you for
Tara
that,
was a
and
pit
I
bull,
can't wait
and
to
you
hear
were
from this.
organizing everybody. Yeah. Very good. Didn't hear that. Sorry.
Thank you for having me on, Carol. It would be great to see you next week at the boot camp, maybe, possibly.
I don't know if that's going to work. It's still all kind of up in the air, but it's not looking good. But what I am looking greatly forward to is listening to you with Krista Pernow and company. That will rock.
Well, thank you. It's going to be cool. I'm looking forward to it. It should be a lot of fun. And we have the just listeners. If anybody's out in Arizona next week, we're doing the MUFON Field Investigator Boot Camp.
Yeah.
You know what, Mark? I was thinking about that. I think we need to Skype you in. If nothing else, I think a couple of great encouraging words from you would be wonderful. And I think we need to do that during class time.
Oh, I don't think they had the Wi-Fi last time I checked, but maybe they do.
Okay, well, we'll look into that. But I think you giving some words of encouragement to all the wannabe FIs and the people that have been there would like to hear something from you. I think that would be cool. So we'll have to look into that.
Yeah, you have to. Yeah. Okay.
All right, guys. Have fun, and thanks again for having me on. This has been wonderful.
You have lots of fun, too.
All right. I'll see you guys later. Thank you.
Enjoy,
Bye-bye.
everybody. Take care.
Bye.
Thank you. Happy Halloween.
Happy Halloween.
Happy Halloweeny. That's funny. So anyway, I don't actually know if I got rid of them. I gotta figure out how to do that.
Okay, so we won't say all the bad things about them until we're sure they're gone.
Yeah, exactly.
Yeah.
Yeah, I don't think they're there. Oh, it doesn't matter anyway. So anyway, folks, this is James Dugan. You asked me earlier if I could do a 1-minute shot of the or 90 seconds, and yes, I can. This a little bit of tracking error here, but the problem is this is very high up. In fact, I can show you. If we go back to our remote view, let me just go there real quick and then show you where the camera is looking. There's an issue, and I'll show it right here as I bring up the size of our dome cam. Okay, you can see.
Oh.
Okay, you can see that the telescope is aiming at sort of an angle, and this is the shutter, the thing that closes. This is why domes are a bad idea for remote telescopes like this. And on the far side of this telescope, what you cannot see is another whole telescope mounted to it, and it's the guiding telescope. And it's actually being partially blocked by this part of the dome here.
Mm-hmm.
And that's the reason that we're getting a little bit of that, what I call walk. It's like walking. The stars are walking a little bit too much. So anyway, so that's that. So we'll try again. We'll try to get another shot for a minute here. Sometimes it comes out good, but sometimes if the tracking isn't right on, it'll miss track, and so that's what we're seeing happen. But
right, and meanwhile, Leanne Mercier or Mercier, I'm not sure how she pronounces that, and Papa Tom and CND Boy are with us.
Yeah, Canada, CND Boys from Canada. Hey there, Amos Cardoza's here. I see he just got here and said hello. How are you?
Oh, there we go. Yep, now I'm seeing you.
Yeah, beautiful clear skies in Western Mass, and you could read a newspaper by the full moon tonight, Amos.
Wow.
And I said hello to you. Welcome again. And Papa Tom, great to see you. CND Boy, nice to see you as well. Happy Halloween to all of you. We're having fun tonight. It's kind of a neat, little get together tonight. I'm looking for more things to look at too while doing this. Go ahead.
And Leanne says, see the full moon dance with Mars. Yeah, now that song's stuck in my head, Leanne. Okay. Wonderful night for a moon dance.
Yes, a wonderful night for a moon dance. Yeah.
Oh, good. Yep.
Okay, well, I'm gonna let this last exposure get done here, and then we'll move to the other part of this nebula that's just as pretty. This is this section. If we look on this shot here, the section we're in right now is right down here. Okay, this is where we're looking right here. In fact, this is the witch's broom right there. Okay, now we're gonna move up to this side. This is a supernova remnant. All right. So when we look at this up close, right, this is the western side, and you see how small and thin it is. That's because it's coming up against lots of interstellar material, and it's compressing it on those shock fronts, like I told you. We saw one of those shock fronts in the other image. And the other side, there are shock fronts everywhere that when we look at that, and the star that blew up is somewhere in the middle here. And now you gotta keep in mind, this is three-dimensional. Some of that stuff's coming toward us, some of the stuff's going away from us. All right, so, but from our perspective, we only see what looks like 2 dimensions. Okay, so I think that's pretty cool. Yeah. So what we'll do is when we get I think our shot is finished. Let's go check it out. Yeah, see, it still has a problem because of the fact that the guider was obscured. It's been obscured, but you see the beautiful wispy nature of this area, and there's that shock front I told you about right there. Okay, so now what we'll do is we'll go to the other side, and the other side is really I don't have to go there I could just drive the telescope over there, but I want to do it and let the telescope do it the way it does it, because it's really cool. So it's going to go and it's going to find the bright star, and we're going to see a bright star come in, and then it will make its way. All right, and there we go.
There it is.
Yeah, and then once it settles down, we can see a star over here. It's kind of tough to see, but it's moving around, and it's just settling on the final location. I think our nebula is going to be right about here, and I'll take a short exposure. I'll do 25 seconds.
And while you're doing that, Francis Palmer poses the question of, is it true that the Earth is flying through a supernova at the moment?
Okay, that's a strange, there's a strange answer coming. I'll tell you why. If we were flying through an active supernova, we wouldn't be here. Because a supernova cloud expands for millions of years. And as it does, it collides with other things. It starts new star formation. It also causes, other stars to have problems. It causes all kinds of crazy things. But, and as I said, it's on the right side. There it is. Okay. But one of the things that's really interesting about these clouds is that in interstellar space, we're always encountering stuff like this. Okay, we're always encountering it. So technically, I can't say we're not and haven't ever flown through supernova debris, because all of the gas that made up the sun and the dust that made the planets in our solar system was forged in the heart of a star at some point, and that star, many stars beyond, probably exploded in a supernova. Okay, so it's possible that actually happened, so I think it's pretty interesting. So I can't say we have never flown through supernova debris, because the fact that we're here shows that we have at one point or another. Now, the interesting thing is we orbit our galaxy, and we've done that 19.5 times in the existence of the Earth, 4.6 billion years, 19.5 times we've gone around the galaxy. And in that time, we've been subject to gravitational forces of other stars tugging on us, pushing us around, moving us around. So if you ask us, where did we form? Can we point to where we formed? No, not really. I mean, we've actually only just recently found our twin brother, or twin sister, if you will look at it that way. Our star, when it was formed in a cloud that was made of the same materials that we're made of, obviously. Well, what we've been trying to do is to find another star, or a bunch of stars, that have the same exact chemical composition as our sun. Because any of the other stars formed in the same nebula that we were formed in, okay, will have this composition. So, our star has a particular number of elements in its spectrum, elements that it was formed with from the cloud from which it was made. That set of elements should be present in another star, and if it is, to the same exact amount, like 0.03% of that, 0.2%, I mean, right down to the little amounts, okay, they'll be the same. Well, only just recently did we actually find a stellar sibling. We found a star that is actually exactly like the sun. It's a twin, and that tells us that we have at least now 2 stars we know that were formed by and from the exact same materials in interstellar space. Isn't that crazy? And so we know we have a sibling now, an interstellar sibling, and that's really quite amazing, you know. So I'm going to just move us a little bit to the west, okay, because I'd like
while you're doing that, I want to tell you that Benjamin Zavala has just revealed that he's turned into a werewolf this blue moon. And in spite of that, he can still type. And Charles Smar has an interesting question. I have no idea the answer.
Okay.
Charles poses this. Are the light effects that are visible 2 emissions from one star with one overtaking the other, or a collision with another star?
Let me read that again.
Yeah, are you looking at it? Can you see it?
I'll read it because I didn't.
Okay, yeah.
Are the light effects that are visible 2 emissions from one star? Charles, what do you mean by that? Could you clarify, please? It sounds like a really good question. I'm just trying to see if I'm just misreading the cadence or something and why I'm getting it wrong. But let me know what you mean by that. No, this is Benjamin Zavala. This is actually the Veil Nebula. That is correct. The Veil supernova remnant. I'm going to do 25 seconds at 32,000 here. I moved it over to the left. All right. And it's high enough up so that the dome is kind of interfering with the guiding a little bit, so you can see that it's not quite perfect. So let's see if the next one comes in a little bit better. You can see the color here, but you also see all these little tendrils. This is an indication of how this layer of material, when it blew off the star, look at that. When it blew off the star, okay, this is more like it. Okay, it actually moved outward in an arc, okay, and as it moved out in this arc that we're looking at right here, it began to compress other gas ahead of it and dust. And here is an example right here of an area right here that's got it's like a shock front. You know, the stuff's coming through, and as it's compressing that stuff, it makes it denser and thinner, and you get tendrils out of it. Okay, same thing right here. Another one right there. That's happening there. That's another example of a beautiful compression along a shock front. And, you know, sometimes, and this is something that can happen too, it might cause star birth all along the way, and you might see a star and another star and another star, and it might make a line. Potentially, those are, and Daryl first mentioned it, Daryl Mason mentioned it in one of the other streams, that this might also be a potential indicator that a supernova shock wave has gone through an area, is to see a line of stars that it created along the way. So it's pretty cool, and and I can't really emphasize this enough, the fact that we're seeing this like we are, in the detail that we are, considering that we have a full moon out, is really, really quite astonishing. Now what I'll do is, just to give you an idea, we'll go back to our other view here, and I will change our filter. This is up here. You see the filter right there. It says right here, it says narrowband 1. We're going to go to narrowband 2, and narrowband 2 is slightly wider pass through the specific wavelengths of the spectrum that have the information we want to see for, like, the details of a nebula. Now I'll do the same 25 seconds at 32,000, so you can see the difference with how the wider bandpass does against the smaller bandpass. Okay. Yes, Francis Palmer, a bow wave, exactly. Did Charles rewrite his question or no?
I didn't. I saw another phrase. Let me scroll.
One wave front overtaking the other. Okay.
Yeah, there it is.
Yes, actually, Charles, that is a very good point. And if this picture comes out, I will be able to show you what I mean by that. Yes. Okay. Now, this is what happens. Okay, with a full moon. You see, look at how bright that is. You can almost not see the nebula, right? Compare that to this. Big difference, isn't it? Okay, that's a big
dramatic
difference.
Yeah.
Okay, this is how it looks with the special filter, that very, very narrow band, and this is how it looks without the narrow band. So you can see how the moon does affect things, but the very, very tiny narrow band can cut through that. So let's go back to this shot. So what you're saying, Charles, is that if one shock front could overtake another, would that cause something? Potentially is what you're sort of saying. And the answer is yes. There are places where the material is expanding outward and it hits other denser material, and guess what it does? It reflects back at the oncoming further shock fronts that are coming out toward it, and those can cause all these tendrils. It goes boom, bam, boom, bam, like a ricochet, and that can happen too. That can happen as well. So that's actually a very, very prescient point you make, Charles. Thank you.
He does that.
He does that. He's got that amazing quality.
You bet.
Yeah, and so I have to say, I think that it makes a lot of sense to consider that people, it makes a lot of sense that people understand. Well, sorry, to me, it makes a lot of sense that we see what we see, and I'm hoping that people can understand that you guys can understand it. If you got any questions about that, let me know. I'll be happy to talk to you about it.
Yeah, well, you clarify stuff, so well. It's for us average bears, it's really phenomenal. Thank you, by the way.
Oh, no problem. Yeah. Okay.
Benjamin just quickly remarks that it's the first time that it's been over 60 years for all of the time zones to have a simultaneous blue moon.
See, now that's the kind of information Daryl would know. He knows that kind of stuff. I'm just an astronomer. I don't know. I mean, I don't know about some of those things. The really hardcore observational guys like Daryl, he'll know a lot of that cultural factoids that I just don't know. I'm more of a science astronomer, and he's less of a hardcore, astronomer versus a astronomer who is familiar with the night sky at a glance. Put him in the woods, he'll never get lost, kind of thing. I mean,
yeah.
And I had to teach myself how not to get lost in the woods via astronomy. For him, it just comes automatically, right? So he's good that way.
Wow. Great pair for you. I mean, a great pairing.
Yeah.
Yeah, you're a good combo.
Anyway.
Yeah, and Isabella is asking, where is Daryl?
Daryl couldn't join us tonight. I asked him if he wanted to, and he couldn't join us tonight, which is all right. I invited Amanda as well, but Amanda is now working with KGRA quite a lot, so
you bet. Yep.
I haven't heard from her, and usually she'll come into the chat, let us know where she is. But
I think she is doing the StreamYard production for my brain is boggling on who it is, but I think she was on the air actually last night on the Don Ecker show. It was very cool. She told some Halloween anecdotes.
Yeah.
And Charles says, thank you, Mark. Very much enjoy your help visualizing the phenomena.
Oh, that's all right, Charles. I'm glad I could answer that. But that is what happens, when supernovas occur. You got to remember, you're used to gravity. You're used to, dropping something like there's a cap, boom, it falls. It falls down, lands in my hand. Gravity, based in the center of the Earth, is how it mathematically is formulated. When it drops to the center like that, we're in gravity, so we don't understand what it's like to have no gravity around us. So when a supernova shockwave moves out, it's moving spherically out in all directions from the star. Okay? And as it does that, there's no gravity anymore. For that central star is very, very massive. Probably that central core will be very massive, highly compressed, but the material is flying out at such a rate that it has reached what's called the escape velocity, and it will go far out beyond. And there's nothing to stop it except the other dense materials that are in the interstellar medium we cannot see. Things like dust and gas. Okay, you might think that gas doesn't impede anything, but then again, if you look at a spacecraft re-entering the Earth's atmosphere, which is all gas, you know that at a certain speed, as a spacecraft re-enters the Earth's atmosphere, it begins to get hot and starts to burn. Okay, and that's why we need heat shields. Okay, so in the same way, when gas is being ejected from a star, okay, it's moving out at a high rate of speed, much faster than a spacecraft enter our Earth's atmosphere, incidentally. And when it hits other gas, it's piling it up, it's snow plowing it. And when it does that, that contact, right, is, and you might say, well, it just moves through, it's just gas. Why is it doing anything? Because it's a mass of gas. Does that make sense? It's a gas mask. No, not gas mask. That's one of our viewers. Okay, but a mass of gas. And as it goes out, you got to remember, in the absence of gravity, this gas moving out has its mass of its own, and thus it has a certain gravitational force all its own. So as it moves forward, it's pressing, just like a shock wave in air, sound shock wave in air, it's pressing material along its front. And so if there's this gas sitting here out in space and this shock wave comes along, it presses it and pushes it along. And now you have this snowplow effect. And now this is denser. But what it's done is, because it's heavier and maybe more massive and dense, then this shock wave that was moving like this fast now slows down a little. But it keeps going. And this part up here doesn't encounter any gas, so it just keeps going at the same speed. This is moving slower, so you get a little warp into this. And if we look here, here, look, you can see there's areas in here that are warped. You can see areas that are like this area right here. This is a beautiful little area to show this exactly. Look at that. Okay, you see this line of stuff coming along, this line of stuff coming along, but then there's like a gap here. Here's an arc. Yeah. Where'd this arc come from? Okay, what happened here is probably related to the mass of the interstellar material that's out there in this interstellar medium. And so it's done this. This material here that you're seeing right here, all right, this material here is actually going unimpeded through here, but this material is hitting something and slowing down, okay, and being impeded by something here. So there's some density potentially over here, and so that's what shapes these remnants. Okay, now there's going to be an initial non-homogeneous, non-homogeneous, for those that want to pronounce it that way, a non-homogeneous way in which it's being ejected from the star. It won't be perfect in all directions, okay? The star will eject it that way, and as it moves out, it'll impact other things, and it will change how it looks as it moves through the interstellar medium. So as it moves outward, it's not going to just stay like this, like a perfect arc. It's going to get splattered and scattered, and it'll end up lagging where it hits something else of mass, like over there. And that's the thing that we're looking at in these nebulae. That's how this works. It's actually, it's sort of like, it's very complicated but simple understanding of physics to see how this is going on. But it's all happening where there's no other gravitational sources other than the gas itself. And so the gas itself can cause these strange things to happen, like right down here. Okay, this area right here. Okay, now that arc right there, that's a beautiful arc, and that arc is example of an area that's being held back. Like this is being held back. This is pushing through, and it's being held back over here. It's like a bubble expanding outward, like that. Okay, moving out into the interstellar medium, and meanwhile, this stuff here is being held back, right? Because there's something denser in here that's kind of causing that thing that was like this to go and get pushed back like that as it moves through, because something else was blocking it. So that is how you think about supernova remnants, which is what this is. It's a supernova remnant. All right. So hopefully that will that helps you to actually see that a little clearer. Right?
It does. It gives a whole different perspective. Tara said she hadn't really thought about Tara said she hadn't really thought about a mass of gas without gravity,
Yeah.
heavy as she puts it.
Yeah.
And Charles has another question: is there any electrical charge in these clouds?
Absolutely. So let's consider what happens if we look at a cloud like this one, right? Okay, let's zoom in just a little bit on my favorite section here in this part of the veil. Okay, you notice this is a little bit red. You'll notice this is a little bit blue. Okay, these are oxygen atoms, and these are potentially hydrogen and maybe some neon atoms in here. Okay, what's happened is, okay, an atom is a proton, a hydrogen atom is a proton and one electron. And that electron is somewhere around the proton, right? We can't say exactly where it is. Okay, there's an uncertainty principle that doesn't allow us to know exactly where the electron is. We just know it's there. The electron has a negative charge. The proton has a positive charge, +1, -1. So a hydrogen atom by itself, with a proton out here and an electron circling it, these add up to 0 net charge. There's no net charge on a hydrogen atom. Ionize that hydrogen atom, though. That is, kick the electron off by having the electron absorb some energy. And now you have a +1 proton left behind. All you have is the nuclear core, that atomic core. The atom's core alone, the nucleus. That nucleus has a +1 net charge, okay? And then, as the electron bumps into other things out here, interacts with other energies, loses some energy, falls back into maybe a different hydrogen atom, maybe not the same one, okay? And as it falls back into the atom, all right, that's called recombination. That's when it gives off light, okay, as it gives off some energy. Now that light, all right, light is, in reality, is an electric field and a magnetic field that are at 90 degrees to each other, okay? So all of the things we're seeing here are electric charge related, everything. So when someone talks about the electric universe, you can't really poo-poo them, but they're the tenets that the electric universe is responsible for craters and things. I just don't buy, but there is a good reason to talk about the way that the universe utilizes electrical charge. There is. That's a good reason to talk about it, but taking it too far is, where I don't go. But I think that when we look at objects like this gas, this is, there's going to be charge in this gas. There will be some charges here. Now, technically, if we're seeing the glow, it means that the atoms, electrons have recombined, and thus brought them back to some type of neutrality. However, we do see isotopes, and we do see charged atoms out there. Isotopes aren't necessarily going to have a charge on them, but isotopes are just atoms that have more neutrons in the core of the atom, okay, in the nucleus, all right? But when we look at this particular nebula, for instance, when we see these things here, we're seeing the light because the electrons have rejoined the atom. But you got to remember that we're not seeing a final result. This is an ongoing process. At any time, if you measure the electric charge of this cloud, you're going to get a net charge of some kind, because not all the atoms have recombined at this point. We're seeing atoms that are still being ionized and still recombining, so there is going to be a healthy supply of charged particles out here, everywhere in a nebula. All right, it's never done, because this light you see that we've seen from, been here for thousands of years, tens of thousands of years for this nebula. Okay, the nebula is expanding, of course, and changing its shape slowly over time. But as we look at it and we watch what we're seeing here, okay, we're seeing that the current state, the snapshot we've taken, is of these particular atoms that have given off that particular amount of light this particular amount of time ago. In this case, a few thousand years ago, not just about under, I forget how far away, 1,600 light years, maybe. So anyway, just about 2,000 years ago, these particular oxygen atoms gave off this light because the electrons rejoined them. But the process of of ionizing and recombining have been going on and on and on. So there's constantly being, +1 protons left out there alone and then recombining with the electrons over time. So there's always going to be some type of charge out in the nebula like this because it's an ongoing process. It never stops. And the only way it stops is if the remnant gets so far from the original progenitor, the thing that made it, that any ultraviolet energy by this particular object down here, which is going to be a pulsar or a neutron star, okay, has long since become too weak for it to ionize any more atoms, and then the atoms will then stay neutral out in interstellar space. But then they'll also be invisible, all right, because you don't get this glow from atoms that aren't doing some type of transition, okay, where electrons are making some type of transition into the atom. All right, that's where this glow is coming from. That's what this is all about. So hopefully that makes sense. And if you're interested in more about that, do ask questions. I hope that answers your question. I know that was a long, drawn-out question, Charles. Long, drawn-out answer to a very short question. But it was a loaded question you asked, and I had to unload the answer on you.
Yeah.
Sorry.
Right. No. You just can't. There is no, 25-word answer to something that profound. Francis Palmer wonders if dark matter energy has any effect on moving gases or other matter slowing it down.
Well, I would imagine that theoretically the answer is, of course, yes. Give you an example. We know that dark matter, for instance, may very well be the reason why stars orbit galaxies the way they do. In our galaxy, just like in our solar system, for the longest time we thought stars near the core of our galaxy are going to go whipping around very fast, and stars out on the outside are going to kind of go leisurely around, okay, because they're farther away and they don't need to go as fast around the outside in order to stay in orbit. Case in point, Mercury takes 88 days to go around our sun. Pluto doesn't. Pluto takes over 245 years to go around our sun. Okay? And so, but it's still contained and held by the sun. So, extending that model outward seemed like a logical thing to do.
Mm-hmm.
Stars farther from the center of our galaxy, we expect to be moving slow around the galaxy. Stars near the center be going a lot faster. Now, whereas it's true that stars near the center do go a little bit faster, it turns out that stars on the outside of the galaxy are moving way faster than we ever thought. In fact, it's not like it's a gradual decrease, as we were expecting that the speed would drop off really steeply as we got to the outside edges of the galaxy. It turns out it's not true. It's almost as if the galaxy is rotating like a solid disk. That means the stars on the outside are moving way faster than we ever thought, and that the stars moving inside near the center are moving way slower than we thought. What could be causing that? Well, that's where your question comes in, Francis. That was an excellent question. Dark matter can affect the speed of this rotation. In fact, the theory right now is that galaxies rotate like a solid object. Think of a phonograph record on a record player, or a CD in a CD player. Okay, the outside edge of those record players or those CDs are moving very, very fast compared to the center. Okay, well, it's not exactly the same thing, but we do see that the relationship shows that there's something else that is causing all of the stars to move more as a one rather than individually, like the classical Newtonian kinematics that explains how the solar system planets orbit around our sun. And that something was this dark matter that we cannot detect, we just see what it does. Now, matter in the universe is divided into different kinds. The kind of matter that we're used to seeing is something called baryonic matter, neutrons, electrons, protons, and so on. Okay, those kinds of things are the baryonic matter we're used to seeing. What we're not used to seeing is the baryonic matter that's acting as if something else is acting on it and we can't tell what it is. That's what the cool thing is. That's what we're seeing out there when we look at galactic rotation. Now, I I think that that particular theory, that particular approach is going to be massaged and changed over time. But I do think that it's going to be holding up, because we do see that galaxies rotate almost like a rigid disk, and that's something. Not quite. They're not a rigid disk, but they rotate more like a rigid disk than we thought. And the dark matter, if the dark matter enveloped all the galaxies, and we couldn't see it, then it would be responsible for helping to cause these stars to rotate at a much faster rate on the outside. Boy, is that too much for your heads on Halloween? I apologize.
I don't know. It's kind of the exploding pumpkin head syndrome, but that's okay. We can deal with it. But now this is the perfect segue to Isabella's question.
Okay.
Talking about dark matter, she has a question. Everyone says that dark matter pushes matter to expand faster. Is it possible that actually something is pulling it from outside?
Maybe a little correction, Isabella. It's not dark matter. In this case, I think you're talking about dark energy at this point. Dark energy.
They're often confused. Yeah.
They're often confused. I don't know if she's talking about that. I think she is, because what dark energy does is, dark energy is like a repulsive force. Wherever it is, it pushes everything else away from it in all directions. An example: if you take a balloon that's deflated and you put all these little black dots on it, and you blow up the balloon a little bit, you see all the black dots. And if you blow it up and blow it up and blow it up, you'll see that every single black dot is moving away from every other black dot, because the fabric of the balloon is stretching. That's dark energy. Okay? Dark energy is the fabric of the balloon. It's pushing everything away from everything else. And it's a concept which is really, really hard to grasp. But if you think of that analogy, it makes a little more sense. Okay, I've talked about this. In fact, I use this analogy when I did talks in Norway. I use this analogy in Arizona, and everywhere I go. When I talk about dark energy, I use that analogy because that sort of helps you visualize what's really going on. Okay,
it does.
And I think that the dark energy, being this repulsive force, it's the reason why we might not be sure how old the universe is right now. We used to say 13.8 billion years old. Now, you know why? Because in 1929, Edwin Hubble, famous American astronomer, figured out that everything is expanding. And he figured out the rate of the expansion. And that rate of expansion was called, no surprise, the Hubble constant. Well, the Hubble constant, as it turns out, isn't, because other observations showed us that the Hubble, the Hubble Space Telescope, for instance, and the Planck telescope, specifically showed us that there was another force at play that was causing the Hubble's constant to change over time. It showed that the universe was actually not moving in a standard regular rate of expansion, constant rate of expansion, but it was accelerating faster and faster every second as it went out. When an explosion first occurs, there is an acceleration outward, right? And then it expands out, goes vroom, and expands, then it slows down. Okay? Then eventually it stops expanding outward, and then you see the cloud go up in the air, especially on Earth, right? Well, in the case of a universe where there's no gravity other than the gravity of the central mass, that explosion goes in every single direction, toward you, away from you, all that. And when that happens, that acceleration would be kind of brief. You wouldn't expect it to be billions and billions of years old. But it is. That's what we're seeing. So the only idea that made sense was that maybe there's this dark energy stuff which is causing the acceleration of the universe. And to Isabella's point, I've heard it discussed that maybe there's something outside the universe that is pulling on the outside of the universe, pulling it open, pulling it from all sides. That was initially what they talked about, but it turns out that they've refined it to think that maybe it's this repulsive force that is pervasive throughout the universe, inside, and it just pushes everything away from everything else. And good luck trying to find out what that is, right? But there is a dark energy telescope that's been created, something to look specifically for this, right? And that's something that will turn up some interesting facts, possibly in the near future, perhaps, or maybe 10, 15 years from now, who knows? Either way, the human race is neophytes. We're neophytes with the universe. We look at the beauty and say, look at this is how beautiful this is. Oh, that's gorgeous. But what we don't know is exactly how it was made. We don't know exactly what types of things go on in the universe that we don't understand. There's some things we don't understand. Believe it or not, in the universe, there's a lot we don't understand. And that's okay. I mean, I don't think that there's anything we can do other than just continue to do our research. Continue to do research. So I think that's pretty cool.
Learning never stops.
No, the learning never stops. That's right. It never stops. Go ahead.
I'm sorry.
No, go ahead.
Well, no, I was just going to say that Tara says regarding, the Hubble constant not being constant, she says, is the only constant change? Yeah. Ponder that.
Tara, that was exceptionally, that showed exceptional mental prowess, what you just said. The only constant is change. Well said. And yes, that is exactly what that means. It means that there is going to be just constant change in the universe.
Yeah.
We're going to another planetary nebula right now, and we're going to see if we can get this. Again, I don't know if the telescope is well placed for it or not. I'll let you know. Maybe. We'll see. But one thing I'm going to do is I am going to take us back to... we're on narrowband 2. Good. All right, good. Narrowband 2 is where I wanted to be. Gives us a little bit wider. We can't do any white light photos like you'd see with your eye because everything will be blown out because of the unbelievable bright moon, which is right nearby.
Wow, what do you know? So Francis Palmer has a sort of listen to this. I'll just read it the way he typed it. The red shift at the edges of our universe is moving a lot faster than within. Is that because of less gravity, or what Isabella was referring to?
Oh, that's a good question, Francis. No, the red shift farther out, okay, is the same in all directions, okay? It looks like the farther away, that's called recessional velocity, how fast things are receding from us. And when we look out in the universe, the farther out we look, the faster things are moving away from us. Okay? That recessional velocity is what Hubble was studying. And the rate at which it's expanding, at the time he did his study, it was constant for him, because he studied a whole bunch of galaxies and got a recessional velocity, how fast it was moving. But what he didn't get was that the recessional velocity will change, and that the acceleration that related to the expansion of the universe, the Hubble constant, that's something that he didn't know was going to be different. And it doesn't have to do with the fact that it's far out in the universe. It has something to do with the fact that has a lot to do, in fact, to the fact that the great distance involved will affect how we see the speeds of these objects moving, in part, and that's something that we have to also consider. I'm trying to locate something here for you.
We located Daryl. He is in the house.
Hey, Daryl. He said he would stop by if he could. Say hi. Yeah. It's a really bright moon out there, Daryl, but Happy Halloween to you. Yeah. So we had a very good night so far, haven't we?
Oh, excellent.
Yeah.
Excellent.
Even with the full moon,
night.
look at this. We caught the beautiful, Eastern Veil. Okay. And then we did the witch's broom. Right? Which is here.
Yeah.
This was the witch's broom. Really, really beautiful. So let's go back here. Let's go to this is our current photo. I was trying to locate this little tiny planetary, but unfortunately the problem is the planetary is going to be blue, and as you can see, so is the sky from the moon. So it's going to be like needle in a haystack. So that isn't going to help us too much, but we can go see if we can find something else. Let us look.
Now, circling back, Tara
Yes.
has a question. Did the formula change?
The formula for
And I think she's referring to Hubble. Is that right, Tara? She'll tell us in here.
okay.
Yeah, and Francis says thank you. Sorry to put you through the questions, but it's exciting stuff. And yeah, that's why he's here. That's why he and Daryl are here.
There's no Francis. There's no problem asking questions. They're just all good. You know, it's all good.
He says he's been studying cosmology for 30 plus years. Francis Palmer has.
You know, I got a little something for you, Francis. You know what I say? Hey, Cindy Murphy, by the way, hi. One of the things that I say is, astronomers tell you what that thing is in the sky. Astrophysicists tell you how it might work, and cosmologists say, why does it work?
That's good.
That's kind of how I view cosmology and so forth. So I talk about it that way. So it's kind of a neat little way to think about it.
Yeah, and back to
Hey,
Tara.
Amanda's
it was
here.
the Amanda, Danny Fan 1. Hello, my dear, so good to see you.
Yeah.
Tara says it's the formula. She was talking about the formula changing, the formula to calculate the expansion of the universe.
Oh. Well, yeah. I mean, obviously the formula for the expansion of the universe has to take into account dark energy now. So things got a lot more complicated, Tara. They got quite a lot more complicated. Amanda or Daryl, would you like to come in? Just let me know in the chat. I have no problem if you wish to come in. It'd be great. If you don't, it's okay. Okay, this is Measure 15 up here in the corner. And I believe that we might... Yeah, see, the telescope is being occluded by that thing again.
Ah.
Yeah, that's okay. Yeah, just... let me know if they say they want to come in. If not, I'm just going to keep
I will
things
let
here.
you know. I'm watching.
No worries. No worries. All right, I'm going to head over to the west. And go toward the
Daryl
south.
says he may in a few.
No problem.
Maybe. Yeah.
Okay.
Okay.
All right.
And Amanda says that she's heading to a Halloween show at ERT in about 15 minutes. And
Okay.
she puts
And
up
she
a
puts a link.
Mixler link. Yeah.
Yeah, if you guys want to go to a Halloween music show, go over to Ronald on ERT Radio and hang out with him and Amanda.
And I think Johnny's part of that tonight too.
Oh, is he?
Johnny Unitas.
Okay,
yeah, I think so from earlier.
Yeah.
She'll tell me if I'm wrong. Yeah, it is. It is. I can't speak. It is Daryl and not KGRA. Alan B. Smith is at KGRA at the moment, holding down the fort over there.
Okay.
Yeah, but anyway, I'm just so happy to be here. This is, it's a night for the heavens.
Oh, talk about night for the heavens. Look at this beautiful.
Oh my God.
Globular cluster. Look at that. That is stunning. Look at that.
Wow. Oh my God. Look at that.
Look at how beautiful that is. Look at that. Oh. Now that
What is that?
This is a this is what we call a globular cluster, and these are among the oldest, some of the oldest clusters in the galaxy. And what they are, this is Messier 15. Okay, it's 32,000 light years away. So you're seeing this as it was 32,000 years ago. Oh, now, here's the thing that I love about these, and when we talk about the globular clusters, okay, and we have Messier 13 up, Daryl will tell you about the propeller, which is this interesting feature you can see kind of in the void where the stars are not, and so in this one it's more uniform. Look at this. Now, this is a collection of stars, probably, I don't know how many per se in Messier 15. If Daryl knows, he can mention it, but I think it's got to be in excess of 45,000 stars. Okay, and I'm going to take another photo of this, but I'm going to do it with the other filter, so we'll see it darker. All right, and let me just do that as well. I'm just going to quickly go back, and I'm not going to change the screen on you. I'm just going to leave it there, and then we're going to go to narrowband filter 1, which I just got us there, and now I will head off, and there we go. We're taking that picture. Now let's go back. Okay, so these guys are called halo objects. Okay, what are halo objects? Halo objects are not part of Halo, the game. Okay,
yeah, right.
Looks like my face is being illuminated by this globular cluster. It's so bright.
Yeah, look at that. No, it's wonderful. Get your sunglasses.
Yeah, it's like, oh, it's bright. Halo objects are objects that are in our galaxy, but our galaxy is a disk. Okay, there we go. Look at that. Oh, yeah, look at that. Okay, halo objects. Okay, the galaxy is a disk of stars, right? Okay, spiral arms, but it has a bulge in the middle, a nuclear bulge right in the middle. Okay, but then it has objects that are orbiting it outside the galaxy, and plunging through the disk every few million years. Okay. That's the globular clusters. They are halo objects. They're way outside and they're orbiting around the galaxy. And the truth is, no one really knows where they come from. No one knows how they really formed. But everybody knows that these stars are among the oldest in the galaxy. And the reason is because we look at their compositions. When we look at these stars that make up these globular clusters, we'll see that every one of these stars in here is what we call metal poor. What does that mean? Metal poor means they don't have any elements really beyond helium. So that periodic table, that ugly table you saw in high school chemistry. Yeah. It's hydrogen, helium, all the way on down to 119, 118. Okay, well, these particular elements that are called metals are anything beyond helium for astronomers. It doesn't mean astronomers don't know any chemistry, because we do. It means that the stars have a very high proportion of hydrogen and helium in them. An odd proportion. It's ancient proportion. So these stars are among the oldest in the galaxy. It's really quite a fascinating cluster of sets of clusters we have. And we took pictures of Messier 33 in Triangulum, which is another galaxy with very loose spiral arms. It's sort of face on. So we took some gorgeous photos of it. You can see the globular clusters in that galaxy from here. Okay, and that galaxy is over 2 million light years away from us. Okay, this cluster is 32,000 light years away. So I think that is pretty cool,
And the color is extraordinary.
The color is beautiful.
Amanda blue, right?
Yeah.
Yeah. And Daryl is wanting, he says, give me a holler, and I think he means ring him up.
All right.
And Amanda is heading out and wishes a great evening and a happy and safe Halloween to everybody. Right back at you, kid.
Yeah.
We'll talk tomorrow.
All righty. Daryl is on his way, ladies and gentlemen. Daryl will be in the house in a moment.
Give it up for Daryl Mason.
Give it over there.
The crowd goes wild.
Yeah.
Yeah, and by the way, back to when you were had that bright light, Tara was saying, "Don't go towards the light, Mark." Okay.
No, I had that opportunity. I I chose not to.
Hello, everybody.
Hey,
Yeah, thank
Daryl.
heavens. Hey, Daryl, how are you? How's your Halloween?
Quiet. It's the way I wanted it this year.
That's good.
Yeah.
I'm good. Mark, are my sound levels okay?
You're a little low, but I'm trying to adjust the mix right now, Daryl, to make you make it.
If I need, let me know if I need to turn it up.
Okay, it seems like you're hanging out okay here. It seems like it's okay. But folks at the chat will let us know. But thanks for joining, Daryl. This is Measure 15, as you already know.
15.
Measure
I thought
15.
it was.
I thought they said it was Measure 15.
Yeah. That's my boo-boo. I thought it was 13 too. Oh.
Oh yeah, no. It's Measure 13
Yeah.
is a lot bigger than that. Measure 13 is actually about this size.
So
the size
this
of
is
the other.
I saw you setting up sort of northeast of Altair, I think, and I was thinking, of course, 13 is at Hercules.
Yeah.
Your guess is as good as mine as how many stars are in there then.
Yeah, I don't know, and I'd say it's probably at least 40,000. And again, one of the things to keep in mind too, and Daryl knows this part. I'm just for all of you guys. In a galaxy that has a lot of stars and a hub like that and the disk, when these globular clusters start bolting through the disk, you understand, as you can see, there's a lot of mass in those. These things are massive. They've got a lot of massive stars in here. So as they come bolting through the disk of the galaxy, they're going to do a couple of things. They're going to pull additional stars with them, okay? And they're going to leave potential stars behind, because like in physics, we have something called the N, as in November, N-body problem. And that just means, N number of things you have to try and solve motions for. Star clusters like this are absolutely horrendous to try and calculate all the gravitational interactions. Hey, Tasmaniac. Thanks for coming.
Wikipedia says over 100,000 stars in M15.
Awesome. Okay.
Whoa.
Yeah, I didn't
Total luminosity is over 300,000 times out of the sun.
That's
my
huge.
gosh.
Yeah, thank you for looking that up, Daryl. So, when we look at a cluster like this, we know that it has such mass to it that it's going to be a gravitational center. So some of the stars we see in globular clusters, actually do come from the disk of the galaxy, and they got pulled off as it's come through the galactic disk at one point or another. And the reason we know that does happen is because we've actually seen in these old stars, in some of the globular clusters, we've seen planetary nebulae. There's only about 4 or 5 globular clusters, maybe 6. I can't remember. I think 4 well-known, where you actually have a planetary nebula that is a dying star within a cluster like this. Most likely, my theory is that those are captured stars from the galactic disk as this cluster went through the disk over and over, because it does orbit. So think about it. If you think that these stars we're seeing here, most of the stars are metal poor. They're only hydrogen and helium and maybe a couple other, maybe some carbon here or there, but mostly hydrogen and helium. Everything else, like I said, we consider not metals, which is, I know, ridiculous. How is phosphorus a metal? I get it. But the point being, that tells us something about how the morphology of these clusters, how they form and their paths. If we can figure the path out of these globular clusters, we can see where it goes through the disk, if it goes through the disk. Some of them are so far out that they may not impact the disk at all, or may have never come that close in their entire existence. But man, this is just beautiful. And just, Daryl, so this is narrowband 1, the narrowband filter. So with the full Halloween moon, with the full Halloween moon, we're still getting a beautiful dark image. Yeah, so it's pretty cool. Yeah, so that's...
Yeah, and here's something that I want to know too. Francis Palmer says, why don't they hit each other? And Isabella opines maybe some do hit each other. What's your take on that?
Well, I'll let Daryl talk about that too if you've got any ideas, but I do have some ideas myself. But go ahead, Daryl, if you want to mention it, or if you want to say something here, go right ahead.
I don't know.
Okay, all right. Okay.
I
Fair
think
enough.
it looks like an interesting concentration off center at about 11 o'clock to the cluster.
Yeah.
Well, golly, what can I say? I wonder if that's a foreground object or actually part of the cluster. They're orbiting a common center, I guess, and, well, golly, I don't know. Go ahead.
All right. Well, my theory is that as compact as that looks, you'll have to come back when we use Space Engine and go through some of the globular clusters in 3D. I take people on a tour of the universe with Space Engine, and we actually go into globular clusters. And when you're in the middle of a globular cluster, you'll see that even in the center, as compact and as many stars as there seem to be there just isn't a possibility that they're going to collide. Because the stars themselves can end up orbiting each other, okay, and maybe over time they could decay in their orbits, which does happen. If they get into really close orbits, they can decay, and then finally they can become in contact with each other. All right, but that process of collision and boom, that doesn't happen in globular clusters, and that hasn't happened in a lot of clusters actually at all. And it is because what's that? Go ahead.
No, I'm sorry. Finish your
Okay,
statement.
I was going to say that when we look at how this n-body problem works, you have to keep in mind that every star you see there is actually the tiniest point of light. It looks like they're so densely packed, but they're really not densely packed. If you could see them without any of the effects of the saturation on the film sensor, the image sensor, then you would actually be able to see that the stars are just little tiny points, and you could see better why collisions would not be very likely.
Okay. This is wiki, so take it with a grain of salt. But
We have to, yeah.
it's 175 light years in diameter. Blah blah. 360,000 times the luminance of the sun. And Messier 15 is one of the most densely packed globular clusters known in the Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars surrounding what may be a central black hole. Considering all that, you may well have, stars running into each other there.
Well,
and maybe sort of like Sagittarius A star in the middle of our galaxy, some of them are probably interacting with a central black hole.
well, we know that the SAG-A, the 10-year study shows that there are stars in highly elliptical orbits there, and some in more gradual orbits. There's no doubt. Now, the question is, do all globular clusters have black holes? And is that why they're globular clusters at all?
Good question.
And where did that black hole come from? That's the question.
Oh.
Right?
I have heard some globular clusters, at least, some think that they are the remains of like the centers of satellite galaxies to our Milky Way, for instance. That the Milky Way stripped away all the outer stars, and what's left is like used to be the center of the satellite galaxy.
That would imply, because we see, and it could be true, but that would imply that every galaxy we see had potentially hundreds of satellite galaxies.
Yeah, well, we have them. We have a few at least, or at least a few left. The Magellanic Clouds, Sagittarius Dwarf Galaxy, and others.
Yeah.
And, they have certainly been tidally or disrupted by our galaxies.
Oh, for sure. I just, I'm wondering if we look at, for instance, say the Andromeda Galaxy or Messier 33, and some of the other galaxies, like the Whirlpool Galaxy. I mean, when you have satellite galaxies, one of the things that can happen is the galactic disk can get warped and twisted because of the interaction with a satellite galaxy. And we don't have any evidence of a warped disk per se that could come from, say, galactic disks. Galactic satellite galaxies. But you never know. I mean, we don't know, and we don't know enough. But because globular clusters all kind of have the same look, that implies that they are probably a common ancestral origin.
Well, yeah, ancestral maybe being the key word. I mean, they're older than most galaxies.
Yeah.
Maybe they helped form galaxies.
We do not know.
Who knows?
We do not know.
That's interesting to speculate about. Can you zoom in on that anymore?
Yeah.
All right. That structure up there at about 11 o'clock, that's kind of interesting looking.
That guy right there?
Yeah.
The little void?
I mean, it looks sort of dark around the outer edges of it, but then it's kind of pointing up and away from the center of the cluster.
Yeah, right there. You see a little point. You're right.
Uh-huh.
Yeah. I was telling people how you, I don't know if you were listening earlier, but I told people how you were talking about the propeller in Measure 13.
Yeah.
Okay, and how you're very good at seeing those things. But this is another, you're right, there's a void here. Now, is that a void because I just need to take a deeper exposure and there's really more stars there? Sort of looks like there might be some. Maybe they're like closer to us or farther from us, but fainter. I'm not sure. But still, you got to wonder.
Yeah, if you look closer at that, there appears to be another sort of semicircular shaped void almost running from about 12 to 3 or 4 o'clock.
Right.
And
right here?
no, up at about 12 to 4.
Okay, so 12 to 4.
Down just a little bit.
Yeah.
Right there.
Yeah.
Kind of a semicircular dark shape.
Yeah.
That right there.
Yeah, and it sees that, does that.
And
one
whatever that projection might be that's pointing up toward 11 o'clock, there's a little one directly down under it between it and the center.
Yeah. I think that this line right here, for instance, and this line right here, these might be artifacts of the high ISO. So those things, these are definite for sure. The ones you pointed out here and here, the one I'm seeing here, those are definitely there. But I think that's because of the non-homogeneity of these clusters. They're not perfect, and we're seeing them in a snapshot of time. They're all moving around each other, like you've mentioned before, orbiting a common center. But they are also very dynamic. If we could see these in fast motion, they'd all be doing this. Everything would be orbiting each other. It'd be crazy. Some of those stars, upon orbiting, will get this and get ejected from the cluster.
Sure.
As well, and we don't know how many have been ejected from these clusters. We can tell by something called proper motion studies, which I actually have done proper motion studies, and not of globulars, but sometimes the motion of a star gives you a great deal of information about not only where it's been, but why it was accelerated to such speeds. And when I did my thesis in astronomy, what I did was I was looking for B-type stars, which are very hot blue stars. They're not as hot or blue as the O-type stars, which are the top of the food chain when it comes to stars in terms of that. But the B stars are next. The Pleiades are B stars, for instance. And I found a number of B stars that are racing out of the galaxy at unbelievable speeds. And they're called Runaways. And it was really quite a fun project to do, searching for these runaway B stars. Why are they running away? What do they know that we don't know? It's like, where are you going? Get back here. But the reason that they ran away, each of them has a different story to tell. They weren't just like a cluster of stars. Okay, they were individual stars. So typically, what that means is they were formed in a cluster. They're only a few million years old. Okay. They were formed in a cluster, and then they had this gravitational interaction, and they suffered a whip where somehow the gravitational force, it was a very tight spiral, very tight elliptical orbit, and boom, these things got thrown out from a say a B star young cluster. Unbelievable. Hey Cheryl, Texas, how are you?
And that sort of leads into what Isabella observed. If the clusters are so old, maybe the stars came to some sort of gravitational equilibrium with time.
Well, nothing's ever at rest, Isabella. So when we see stars like this, they can't just sit at a certain distance from the middle of a cluster unless they're at a special point in this cluster that would be what's called a Lagrange point. Lagrange points are parking spots in space, basically. There's Lagrange points around every star. Okay, there's Lagrange points around every planet in relation to the star. And there'll be Lagrange points in relation to stars next to each other in space. This type of situation here, with this cluster right here, we would certainly find that there are many Lagrange points somewhere in this cluster where certain stars are feeling relatively little pull from the other stars because all the many stars that are tugging on them are tugging equally from all directions, and so it's almost balanced. That's kind of what a Lagrange point is. Now, it doesn't mean a whole lot when it comes to stars with you have hundreds of thousands of stars in a cluster, because most of them are going to be in rapid motion around each other. But again, snapshot in time. I would love to be able to do a study on, say, one globular cluster over, say, 10 to 20 years. Take images and images and images of the same cluster for 10 to 20 years, and then compare it and see if we can detect any of the motion visually. And the answer is you probably wouldn't. You'd probably have to take pictures for about 150 years, maybe 100 years. Because with the supernova remnant called the Crab Nebula, Measure 1 of all things, 100 years of photography shows it expanding. And it doesn't just go, it's actually this much. It goes, and that's about it, over 100 years. Space is vast. Objects are huge. So it takes a long time to see motion. But I'd love to see what's going on in the clusters. I'd love to just be able to look at those clusters and see which way the stars look, say, 100 years from now, and compare them star by star. I guess I don't have a life.
Astronomical time machine.
Yeah.
Could you grab another image of M15 there at the same settings? We can compare the two.
Sure. This will be another 25-second shot at 32,000 ISO. I could probably go lower ISO, but I am using the narrowest band filter.
I'd like to keep it the same. I just want to see if what we're seeing there is real or if it is artifacts.
That's fair.
Yeah, and I have a question for both you guys. These things we're about to look at the 11 o'clock and then the 12 to 4, is that, in your perception, that's a difference from the last time you saw this?
No, not necessarily.
No. Okay.
Okay, so this is...
that's why I want to see another shot at the same exposure settings to see if we really see much of a difference.
Right.
I'm looking at a couple of images over at the wiki article. Okay. I still see the semicircular shape at about 12 to 4, 12 to 3 or so. I still see the bright thing up at about 11. Looking at images at the wiki article, M15 is pretty smooth looking. I mean, it gradates from the outskirts toward the center where it's highly concentrated, but otherwise it's pretty smooth.
Yeah.
And the dark lanes that I'm evidently seeing here, even though we saw them in both images, don't show up well in one of the images they have up at Wiki.
I wonder if that's because we need to just do like a deeper shot.
Possibly.
Yeah.
And in the observatory image, they show what looks like a bright star. The image is mirrored and maybe upside down from what you're showing, but in the particular image I'm looking at, it looks almost like a foreground star. what maybe that thing at 11 o'clock is.
I mean, this one here? This one?
I'm sorry. Yes, that.
Okay. Yeah. And that's another thing, too, guys, that you have to understand, too. Like, if you look at this cluster, you can see that this thing looks, like, brighter than the rest. And it could be that it's probably a star that's in the foreground, because, remember, this is, according to what we saw, tens of thousands of light years away. Okay, so there is a likelihood that you're going to see other stars superimposed against it in the foreground. So maybe this star is possibly a foreground star. That star apparently is a foreground star. And you'll see that happen, a lot with many things. You have galaxies that have stars in front of them that you would think are in the galaxy, but they're not. Paranormal Pop, how you doing?
Yay, Alan. Hey.
Is that Alan?
I believe that is Alan.
Alan? I didn't know that's you.
I think so, because that's his, sister show for Paranormal Now.
Okay. All right. Well, if that's so you're saying that's Alan
and
B.
if it's
Smith?
not, then oops.
Paranormal Pop, are you Alan B. Smith? He'll tell us. Maybe he doesn't want to.
I'm not.
Maybe
I'm
he doesn't want to
be
outed about it. So.
There we go. He's in disguise. Well, it's Halloween. Yeah, it's him. Yeah.
Yeah. Okay. So Alan B. Smith. Now, Alan, please post your show times, please, and your links so people know. I plug Carol's show, so please do yours as well. I want people to understand that your show is on, and it's absolutely a brilliant show.
And he just popped up on my Skype saying, yes, it is Alan Smith. Fantastic.
Okay.
All right, so Genghis Khan is in the house,
hey,
and
Genghis.
Happy Halloween. And so, Alan, throw up a link for Paranormal Now. You just got the invite from Mark.
Yeah, please do. And I always support my wonderful friends on KGRA because, I want them to support me. I want to support you.
Yeah, you rock for that. That's just amazing.
Oh, they're good people. You're all good people, right?
I know, it's a great family. It's just extraordinary.
It is, and it's fun doing this, so I'm really, really happy about it. I feel bad. I won't be able to have shows beyond November 9th for the rest of, to the 23rd anyway, of November, because I have to do that. I have to do that filming, unfortunately, for almost all that time. We're going to be out in New York State doing all this filming.
We will miss you. Oh, but you'll have a blast.
I hope so. It's a pilot for a series, so I think it's going to be good. And we'll see how it goes. All I know is they're getting us lots of toys. What's that?
The show's on A&E?
No, that one was called something is out there.
Can't keep them all straight anymore.
No. I don't get I don't do a lot of these. No, this show is actually on a different channel, and I think it's Travel Channel.
What's it called?
No name yet. It only has these code names. They don't have the actual names, so I don't even know the name yet. So, but
sometimes they stick with a working title for a while until.
Yeah, it's a working title is what it is.
Yeah.
And I'm one of the cast, so I guess that means that there's 3 of us. Okay, and I'm working with people that I know. One of them is actually a very good friend of mine, and he's a brilliant guy. As I said, I don't know why you need me. Okay, you know all this stuff. I don't, but I guess for particular sets of expertise, they want the difference. I guess, but it's cool. But I don't know. So that explains. That's why I can't do a show between the 9th of November and the 23rd. But then on the 30th of November, I'm going to be in Arizona until the 13th of December, because I'm sending all the equipment out, including this telescope here that was taking this. And this telescope will be set up in SkyTour LiveStream West in the observatory, which the building is all finished. And if you haven't been up on my Facebook site or on SkyTour LiveStream Facebook site on Facebook, you can actually see the roll-off roof working. Does a really nice job. You know, this big, beautiful roof just rolls right off the building and comes right back on. Yeah.
Yeah, that pivotal part, it comes right back on.
That's kind of important. You know what we're going to do? And one of the guys that was helping me design it, he really, really, really wanted us to use these what are called linear actuators to just basically lift the lid like a box and flop it over and then put the lid back on. That lid's 11 feet by 11 feet in size. And I just couldn't trust that 11 by 11 was gonna that size. That's a huge wind, weather vane, right? Wind vane. So we can't have that kind of. I didn't want to have that kind of mass up in the air.
Yeah.
12 feet over, actually 16 feet over the desert floor, and because the walls are, 5.5 feet tall. I didn't want that to catch the wind, and that would be terrible. The roof is almost flat. So it's almost flat, but it's got a gentle slope to let any water run off, because we do get water out there.
Yeah.
So it'll be exciting to be able to go live in December, which pretty excited about.
I think we're all pretty excited. Of course, not as excited as you, but oh my.
Oh, I'm excited, but I don't care either way. It's not a big deal. No, I'm kidding. I'm very excited. I am. I'm just beside myself excited. I think it's.
It is the realization of your dream.
Well, it's gonna help me. I think it's gonna help me get the word out. When you guys see what we're gonna do out there, this telescope is gonna be one that we're gonna have out there. And I'm also going to very quickly, I'm going to measure 2 now, Daryl, just so you know. This telescope is going to be one of 2 that we have in that area. We're going to have a 3rd one in there as well, that another group is going to rent from us. And the 2nd telescope is going to be a wide field view. And we're going to have a wide field system that we're going to be able to take just glorious Milky Way shots, and then use the other system to take glorious close-up shots. Okay, and so I can't wait for that. I'm already planning on the 2nd pier, and I haven't even got the 1st one in yet.
Of course, forward momentum.
Yeah, I know. Yeah, and by the way, the name of the observatory is now public. It's going to be called the Maudlin Hain Observatory. Maudlin because of the property it's on. Is the property owner is also my friend, who is a former Lawrence Livermore scientist. And Hain because Hain was the one of the major benefactors for the observatory. So
fantastic.
I want to memorialize both of them. And immortalize, I should say, both of them for their efforts. Okay, let's take a picture here and see if measure 2 is in here now.
Fantasy Ecstasy is here just in time.
Hey, Fantasy, how you doing? Happy Halloween.
Yeah, she said she didn't get the notification from YouTube.
Oh,
yeah.
Not my fault, man.
He didn't do it.
It's kind of funny because I have friends who tell me they got the notification the next day.
Ooh.
Literally, the next day. Come on, really? Oh, measure 2, what do you think you're doing? Look at you.
Oh my gosh.
Yep. Now, what's neat to look at these is because you can see the difference. Okay, like Daryl, look at this, right? You talked about the voids. Look at this one. Looks like it has horns.
Yep.
Okay, measure 2 has its own things. And undoubtedly, we're seeing a snapshot in time of all this complex stellar motion. So at this point in time, that particular thing that's facing us happens to have a what looks like a horn of stars rising up, but those are actually stars that are in gravitational orbit around other stars and around a common center of gravity within this cluster. And it looks... Yeah, go ahead.
Looking at images over at M2's wiki, I can kind of see, and they have the 2 micron all sky survey, an image from that, and I can almost see those horns in the image there. Other ones, they're deeper images. I've never heard of the telescope, but it's a little more regular looking. M2 is a good bit larger, but a good bit farther away than M15 is. Probably why it looks a little different. They say it's 175 light years across. It's 55,000 light years away, and about 150,000 stars.
Okay. Still, that is just an amazing object. Let's take another one because...
look at that. Yeah, I see the horns now.
Yeah, sorry.
Yeah. No, it's okay.
I want to get us to this again here. Now, in this next one, let's see if it's going to be a little bit clearer. Temperature is really cold today. It's like 30 degrees out there or less.
Oh, it was 84 here today.
Go away.
California.
I'm going to hang up on you.
Okay, bye. No.
Okay. Well, there you can see those horns really nicely.
Yeah.
And I see sort of a dark feature down at lower left on that one.
Okay, like this right here? Or are you talking about over here or here?
Lower left, closer toward the center.
Okay, so right there?
Up a little bit. Well,
right there.
May be part of it.
Yeah, I kind of see. Yeah.
Sort of a line or 2 lines.
Yeah,
there.
like that.
Mm-hmm.
Yeah, I see that. There's one here too.
Those horns really stand out at the top right there.
Yeah, they do. That's cool.
And I see a big void over at about 3 o'clock also.
This here?
Yes.
Okay.
Looks almost like a big number 6 sort of laying on its side.
Yeah, it does. Yeah, like right here.
Huh.
Well, closer up, right there.
Okay.
Just to the right of the center of the
Yeah. Very cool. I'm gonna actually go back and increase the time here. I'm gonna go up by 1 stop and down by 3. So it'll be a little brighter. I'm sorry, a little longer exposure, but a little bit less noise. I wanted to see what we can get. Because it's kind of muddy.
Is this Messier? Is this 2 or 3?
2.
2. Okay.
The second object in Charles Messier's catalog.
Messier. Okay.
Yeah.
Messier was not the first to see it. A couple of other astronomers were, and maybe commenting on the quality or lack of Messier's telescope, he didn't see any stars. He just called it a nebula.
Mm-hmm.
And William Herschel was the first one to resolve it into stars.
Okay.
Fantasy, it's in Aquarius.
Oh, look at that.
Well, that's pretty. I did the lower exposure, lower sensitivity so that I could get rid of some of the noise. To kind of flesh out those horns a little bit. Interesting. Very nice, very nice, very nice. Let's go back to our... So far, I've done this without having to move the dome, so...
Yeah.
I'm just sort of waiting for things to come in. But we're still in the southwest right now, so we do have the ability to move over just a little bit more. Well, let's try. Where is it? It says Neptune's there. I want to see Neptune. That ain't it. That's got to be Neptune. Okay. Should we check out Neptune if we can?
Oh, yeah, buckle up.
Okay. Buckle up, Buckaroo Banzai.
Oh, God, I love that movie.
Remember the Chinese guy running across the water at the end?
Oh, right. I saw it not too long ago. And, yeah, in other times I could see this as a stage musical. It's got so much music in it. Yeah.
Very cool.
But wow.
John Big Booty.
Yes, right. Yeah.
Hey, guess what we got there?
Well.
It should be Neptune. And it's gone. So maybe it wasn't. That happens sometimes. I don't understand why it happens sometimes, but it does happen sometimes. Well, Neptune was there for a minute anyway, and then it blew away. I don't know why.
We're assuming it is still there, right?
Oh, no, it's there. Yes, of course. But I do not know why it did that to me. That's something that I have to figure out. The database is not. It's not really my fault that the database is not working correctly. Sometimes it does that all by its lonely, and it's not my fault. But I can find Neptune a different way. And I'm going to see if I can make it work.
Meanwhile, Genghis Khan says, so what's up with that rare metal asteroid 16 Psyche? In other news?
Genghis, I don't know a lot about Psyche right now, actually. Daryl, do you know anything about it?
Oh, just what's been in the news recently.
Yeah.
It's worth hundreds of trillions and oodles of dollars. They think it's a very high metal. Has a ton of metal in it. Mostly are all metal, and I have heard said elsewhere that if they ever were successful in harvesting it, it would break the world's economy. It would cause a crash in the metals market, so to speak.
Wow.
Hello, David Schmidt.
Hey, Dave.
Yeah, David Schmidt says boo.
Hey, David. Still over in the Bangkok area in Thailand? Clinking chains, creaking door noises. Scared yet? Yes. Listen, alright, I'll give you a Halloween story that isn't a story. If some of you know, I have a business where I actually I do a lot of work for the Navy, so I build submarine models typically. It's part of my visual effects company. Well, I was building a model in my old house on Oak Street in Terryville, which is it's exactly 1 mile from here. It's 5,280 feet from the bottom of my driveway to the bottom of that driveway. I couldn't have planned that.
That's so wild.
Yeah, couldn't have planned it. And the thing was, when I actually went down one day into the basement where I had my shop at one point, I noticed that there was something over near the wall. It looked like water was coming down and on the wall. I thought, oh no, I got a leak in my basement. What the heck's going on? So I ended up going over to it, and when I got up close to it, I realized it's not water. It's a gray shadow. And I thought, what's throwing that shadow? And I looked at the lights. There was one light over there, one light over there. Nothing behind me that would cause a shadow right there. And nothing that was illuminating it. I put my hand out, nothing. I put my hand over to it and I touched where it was, and I realized it's not on the wall at all. It was actually about 12 inches off the wall, maybe more. And when I put my hand into it, it was like putting my hand in like liquid nitrogen. It was very, very cold, and it hurt. And I just pulled back right away. I was like, what is this? And it really hurt. And I looked at my hand didn't seem damaged. But I literally ran up the stairs. And I locked the door to my shop, and I didn't go down there for 3 weeks. Yeah, it was something that I couldn't understand. It was just really quite frightening. And so then what I did was I ended up going down after about the 3 weeks. I said, I got to get this project done. So I went downstairs and I looked for it again. And it wasn't.
The music's perfect. I just have to say this music's perfect. Go on.
Okay. And it wasn't in the same place. I turned and I'm looking for it, and now I'm feeling creepy because I feel like something's watching me. And I start looking, and I see it on the other side of my basement in the shadows over there. I turn on additional lights. The shadow did not diminish. It didn't get any brighter. It didn't get any dimmer. It stayed there. So I went over to it, and I started to reach again, liquid nitrogen feelers. It burned. It almost burned. So I really started to get angry because I had several $1,000s of project that I had to get done for the Navy. So I lost it. And I literally stepped into its space, taking the full brunt of whatever energy it had, and I said, get the beep out of my house. And I said, you don't scare me, you don't frighten me, I don't know what you are, but you are not going to stay here. If you stay here, it's on my terms, not yours. And I really was pissed. And in that moment, it felt like the air was being pulled out of my lungs, and it went, and it was gone. And I never saw it again. And I couldn't. Now, at first, I'm a science guy. What the heck was that? I had no explanation, and I didn't want to try. I was actually really worried about getting this job done. So at the moment that happened, the moment that noise, that thing went away, I heard a cricket in my basement. And I went over, and it was a metal shelving on the floor. Absolute true story, okay? I'm telling you right now, okay? Look in my eyes.
Yeah.
Absolute true story. I walked over, and I knelt down, and I held out my hand like this, and I laid it on the floor. And I don't know why I said this or why I did this. I said, come on, little fella, you're not going to find any food in here. Let me bring you outside where you find food. I literally said that. And as I said that, this little cricket comes walking out from under the shelf, walks onto my hand, and starts chirping. Have you ever known a cricket to chirp in your hand?
No.
It's going to be rare, right? Now, I can't explain this. So I took him, and here's the thing. I wasn't surprised. It was what I expected to happen. I walked outside. I put it outside in the lawn. It walked off my hand, looked at me, and turned toward me and started chirping again. And I said, well, there you go. And I walked back in, and all the shop felt normal to me. Everything felt good again. Now, here's something about crickets. My mother was Native American, okay, in part. Passamaquoddy Native American, a northeastern tribe. And crickets, you see, would always tell the hunter-gatherers where the game was. Because wherever they weren't chirping, that's where the game was. Wherever they were chirping, well, they were free and clear. There was nothing over there. So this cricket, by chirping, showed me that it was clear now. No threats nearby. See? And it made perfect sense. And I don't often tell this story, and I basically, it is what it is, and I've told other science folks, and they just laugh at me and say, oh, that's silly, but they always say, well, I can't explain that, I mean, maybe you're lying. No, I get nothing to gain from this, okay? Trust me. In fact, it makes me look like a fool to other science people. Why would I do that? You know? So it is what it is. And so, I've come to the conclusion that today's paranormal is potentially tomorrow's science. Okay.
Oh,
and
good.
that's something.
I like that.
Well, no, it's something that I've come to feel. You know, I mean, today's paranormal is potentially tomorrow's science. Just like it was, you know, never going to happen that we'd ever go faster than the speed of sound until we did. You know, so you know, I think that is part of part of all this. I just think it's pretty cool.
It's an extraordinary experience.
It was strange. No doubt about it. No doubt about it.
Sounds like too much LDS in the 60s.
That's funny. What movie?
Star Trek reference.
Yeah, right. Soup Fog says, good story. Hello, Soup Fog.
Hey, Soup Fog. How's it going? Yeah. And then there's a time when I was in 6th grade, went on a field trip to a pond in Connecticut called Burr Pond.
Oh, I've heard this one. Oh my God, this.
Yep.
Yeah, this is extraordinary.
And on that field trip to Burr Pond, I was a 6th grader. I got on the bus. I remember getting on the bus in my short pants. It was like June or something. I was like end of the year field trip kind of a thing. And I ended up sitting on the chair with my bag lunch. So excited to go see Burr Pond. Wow, and it's B-U-R-R, Burr. And so I remember getting off the bus, and then I remember getting on the bus. And I still had my lunch at the end of the day, uneaten. And
as I remember, that was a peanut butter sandwich and Lorna Doone cookies. I don't know. It's my wonky brain. Am I right?
You are correct. It was Lorna Doone's.
Okay.
And I never ate any of it. And kids were saying, "Where were you all day?" I'm like, huh? When are we going to Burr Pond? And of course, they made incessant fun of me because they had been there all day. Well, you know, the school day. So I ended up going home, and that night I was playing with my friend in the empty lot next to my house, a guy named Norman. And Norman, I remember hearing Norman call for my mother, and I remember that my head was slamming on the ground. I couldn't stop it. I was having seizures, and nobody knew why. I couldn't figure out why. I saw ants. I'm slapping my head in the ground. I see ants crawling around, and I'm thinking in my head as if it's not me, going, "Oh, look, ants." I hear that sound of that thud when you hit your head. I felt that. I heard that sound over and over, thunk, 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 as I was hitting my head, and I didn't understand what it was. You know, I just felt, hey, you know, I'm pretty sure this isn't a good thing, but I wasn't scared or anything. I just knew that this was crazy. So I ended up. I remember my mother coming out. I remember all of it. And then I remember that my mother said, "Oh, okay, Norman, you have to go home now." So he left. And my mother called the ambulance, the police to come get me. And they took me to the hospital. And doctors had no idea what had happened to me. They said, "Oh, he has a bump on his head. So maybe he fell. And he's got some sand embedded in there. So I guess maybe he fell." And it's like, well, of course I fell. I was banging my head in the ground in a seizure. So that's what they saw. Okay. Now, what I told them was, well, I think I fell on a dock at Burr Pond. "Oh, okay. He has a mild concussion. He'll be okay. Take him home. Don't let him sleep for a while, because that's what you didn't do. He didn't let you sleep when you have a concussion." And so I got home and realized, you know, that I had just lied totally to get out of the hospital, because I didn't want to have to deal with doctors and tests. And my parents were satisfied, so okay, I was happy again. It wasn't until years later when I met somebody else in Torrington, Connecticut, who lives less than a mile from Burr Pond, told her the story, okay, she and her husband, and she laughed when I mentioned the part about the dock. She goes, "There's never been a dock at Burr Pond." And I go, yeah, well, I had to say something.
Oh.
Yeah. So it was kind of crazy.
Fascinating.
Yeah. So what was that? It was definitely missing time for sure. I'm going to take a 15-second here. I think that there might be, we might be getting blocked here. So I'm going to have to see this image will tell us. Yeah, see, we're getting nothing here. So clearly either we're blocked, that's a photo of the dome, or there's clouds. I'll have to go check. There's not supposed to be clouds tonight. Oh, actually there are. Shoot. Okay. Can you hold down the fort here for a minute while I go? You and Daryl?
Hey, Daryl, let songs, dances, and snappy patter, right?
Something like that.
Yeah.
All right, I'll be right back, guys.
Bundle up.
It was an absolutely gorgeous day here today. Probably not California nice, but Colorado nice. It got up to the upper 60s, not a cloud in the sky.
Oh.
Humidity was down around 12%. I'm sure it's clear out now, but I haven't gone out to look. I need to do that before I go to bed tonight. It snowed early this week, I guess.
Really?
Last weekend. We had those really bad forest fires happening here. They're still happening, I guess. And the snow slowed them down at least. They got like up to 20 inches of snow up north of here.
Oh my
Only
God.
got a few inches of snow here, and then they got almost 2 feet of snow in the mountains down south of here. But then the sun came out like it always does here, and it mostly melted. It's mostly gone the next day.
Well, speaking of mostly melted, yeah, we have clouds. So that was...
Oh, bummer.
Well, you know what's funny is it was just a beautifully clear night. I assumed we weren't going to have any clouds. And I knew that we were going to because I had actually checked to see. And it said there were going to be clouds coming in around 10:15 or so, which is why I started at 8. And
right.
I wanted to get 2 hours in. And it's 2 hours, 38 minutes so far. So unfortunately, this is what we got. But let's review. We got to see Messier 2. Okay. We got to see... let's see, we got to see Messier... is that Messier 15? No?
Yeah, 15, right.
Yeah. And then we also got to see the veil. This is the eastern veil. Wait, let me make it more reasonable. The eastern veil with the narrowband filter, so it really looks pretty over there. Okay. And then we actually got to take a picture or two of the witch's broom. And we were occluded on the dome a little bit, so we couldn't guide properly for the longer exposure, but you can see the complexity in the witch's broom. Several different levels of filaments in there. That's the western veil, the lower end of the western veil, and just out of shot up above is 52 Cygni, that star that we actually took an earlier photo of. Let me see if I can grab that. I think that's a beautiful, that's the one that has that beautiful little thing up the top there. Okay.
Yeah.
And then you got that. See? So then we have 52 Cygni and this beautiful, beautiful nebula. And then we took a picture of the Dumbbell Nebula. All right. And we did that with the wider narrowband. All right. And that was beautiful. And we did some other shots of the Dumbbell.
Right. Isabella reminded us of that.
Yep.
Yes.
Apple core.
Apple core, that's exactly right. Yeah.
Hourglass. Yeah, right.
Oh, Daryl's right. It looks just like that,
It does.
You know?
Yeah.
Looks like an apple core. In fact, that's one of the names people call it, is the apple core, right?
Oh, I didn't know that.
So yeah,
to round out the weirdness, Wise Eye just joined. He said, "This is weird. I was just watching a video of a woodpecker smashing his head on a tree for 20 minutes. Then I clicked on the stream to hear the story of Mark bashing his head." So that is some synchronicity.
Well, Wise Eye, that's interesting. Thank you for coming, Wise Eye. Good to see you. But if you want real synchronicity, how about this? I actually had an experience in the old house where I woke up at 3:15 a.m. every night for 2 straight nights. I heard knock, 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 knock on the siding of my house up high. And I'm on the second floor. It was a cape. And I heard that same thing, tick, 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 ding, 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 the next night. And then I went to check what it was and looked out the window, and I got a flash of white light hit me in the face 2 stories up. What the heck was that? So, and then the third night, I awoke again, and I couldn't move. And that's when the other story that I often tell people, and I've been medically checked for this to see I had CAT scans, MRIs, and what happened was I had something came in the room and was moving this thing under my nose, and next thing you know, I think it went into my nose, because the next morning, and then it was morning instantly, and I woke up and I was actually couldn't breathe, and I pushed off the pillow. It's because I was in a hollow in the pillow, and it was filled with blood. Okay, and it was from my nose, and I couldn't breathe out of this left sinus from that point for 2 years. And I never went to the doctor, and I never told anybody about it until finally, when I did go to the doctor, he looked up there and said, "Wow, you've got something huge up there." And he got up there and he got it out. And I asked him if I could have it. And he gave me a really weird look. And he said, "What?" I said, "Well, tell me how these things can see." He said it was a nasal polyp. I said, "Can these seed around a foreign object?" "You mean like a metal splinter that a machinist might get in his nose?" "Yeah, something like that." And he said, "Well, sure." He goes, "Why?" And I told him the story about the 3 nights of crazy terror and stuff. And he laughed. And he goes, "It's not an alien implant, if that's what you're saying." I go, "No, of course not. Who would say that?" Who would say that? And he says, "Call me in a week. I'll let you know what the results are." So I call him in a week, and I say, "Hello, this is Mark D'Antonio, and I got hold on. Doctor has to talk to you." "What? What do you mean he has to talk to me? What is it? My head gonna fall off? I have a head disease. What's gonna happen?" I had no idea what it was. He gets on and says, "Oh, don't worry. It was just a nasal polyp. Nothing to worry about. Fully benign. Nothing to worry about." "Oh, you got the results?" "Well, not really." "What do you mean?" He says, and don't they always say this? And this is exactly what he said. "Well, this has never happened in all the years that I've done this, in my office here." He goes, "But the pathology group says they lost it." I said, "How hard is it to lose something in a formaldehyde jar or whatever?" I watched you put it in the jar and label it right in front of me. "Yeah," he goes, "it went down, but it was lost." So it's anybody's guess as to where it went. But
how convenient.
Yeah. And then a few years later, I had to go to him again. And when I went to him again, I said to him that I do special work for the Navy. And he goes, "Oh, special projects?" I go, "Yeah." "Oh, interesting," he goes. And then he says, "I just gave up my top secret naval clearance this year."
Oh my God.
"What are you operating on, top secret nasal polyps on somebody?" And he goes, "Oh, no. He goes, "I wasn't always an ear, nose, and throat surgeon." He goes, and he proceeded to tell me, and for those of you that know these places, these things, these programs, he proceeded to tell me that he worked on a program where they shot down an enemy satellite using an EMP pulse from a nuclear weapon fired from the Pacific Ocean. And I said, "Oh, how interesting." And I played dumb.
Oh.
That project, I knew what that project was. It was Project Starfish. Do you remember starfish, Daryl? Yes, he's on mute.
No, sorry, I was on mute.
Yeah, sorry.
I dropped something.
Okay. Project Starfish was a program, ostensibly, to see what happens to an upper altitude stratospheric nuclear explosion. But what they really did was to knock out an enemy satellite with a EMP pulse. You know? And he said he was in charge of trajectories and all kinds of things that were really, really important that stayed classified for a really long time. And he had his top secret clearance until just that year. So, I know how the conversation went.
Yeah.
4 years earlier, hey Pete Pods and Axie, how you doing? 4 years earlier, he probably called someone in Washington that talks about, that was in charge of handling his clearance deal. Okay, I know I was in that same type of thing, and I had the same type of concerns, same type of riot act you were read. You better report, I'm out of it now. I got out of it because I want my life back. And he said, I got a patient, this is how it probably went. I got a patient, says, had a strange event where something got shoved up his nose. And if any of you are familiar in the UFO industry or arena, that's a buzzword for nasal sinus implant or whatever.
Yeah.
I didn't know anything about that then. I had no idea about that. In fact, I thought it was, when I found out about it, I thought it was all a bunch of baloney. Until I started adding it up and saying, well, that may have happened to me. It has to happen to a lot of people if it happened to me. Yeah. So anyway, he probably said, yeah, so I don't know, but just letting you know, under the terms of our agreement, that kind of thing. And they probably said, okay, what's the patient's name? What hospital? What lab? And then he says, okay, thank you for that information, doctor. We'll see you later. And they hang up. He now has plausible deniability. He truly will not know, even under a polygraph test, where that thing went. So.
Yeah, and Wise Eye tosses this in that nasal polyp and formaldehyde with the label is in a warehouse in the Nevada desert now.
Warehouse 13.
Yeah, right.
I know that it's, and again, these things sound crazy, but then again, today's crazy might be tomorrow's science. We don't know. If you think about it, are those things tags? Tagging us like we tag elk.
Yes.
There's a famous Larson cartoon where this elk walks in, the guy has this big gigantic radio collar on, and he doesn't notice it. Okay, it's like we would notice it. We're smart. We're actually not a stupid species. So if they do the sinus tag, well, and they could be either our own government or, something out there for all we know. But if we tag elk, then I think they would probably do the same thing to see where we go, what we do. Maybe it's sort of a behavioral study. Who knows? We do the same thing. We do the same thing with animals. So I think, and yes, Wise Eye, Atomic Test Channel is a great site. I actually, if you go there and look at the Project Starfish, they actually have that. You can actually watch Project Starfish. Here's what it did, guys. Project Starfish was launched from the Pacific Atoll. And I asked the doctor, I said, how could you violate every single treaty for the non-nuclear proliferation of space? Non-nuclear weaponization of space. How could you do that? How could you get away with it? And he smiles at me and he goes, that's why we cleared 1,600 miles of the Pacific in every direction before we did it. Oh, that makes it okay. Yeah. And when that explosion takes place, you can actually watch. You see it's taken with Honolulu in the foreground. Okay, and it's being taken from an airplane farther away from Honolulu, looking toward the blast direction, but with Honolulu in the foreground. You can't see Honolulu until the blast. Then Honolulu's lit up like daytime for just a short amount of time, and then it goes dark again. And that was a very famous photograph that's available online if you look for it. Okay, because even though no one saw the launch take place, from 1,600 miles away, you could certainly see the light of the stratospheric explosion. And they did. So that's pretty interesting. you know. So anyway, hey there, Rover 7377. What's up? We have clouds tonight, by the way, Rover, and to those of you that have been here and just got here, I'm so sorry, but we've been looking at a bunch of objects, and then the clouds came in. They were scheduled to come in later tonight, and this is apparently later tonight, almost 11 p.m. Eastern time. But on the upside, the Arizona Observatory is finished, and we have the telescope that we're using for Arizona is the one that we're using tonight here in the eastern coast, and we have a replacement for this telescope that'll be put in place as well. And we're going to be doing a roll-off roof system here as well, like we already did in Arizona. If you look on SkyTour LiveStream on Facebook or Mark D'Antonio on Facebook, you'll see the observatory in action. A crew of people, including Marianne, Rob, Tara, who is here in the chat now, were just amazingly instrumental in getting this to happen. And I literally owe them my astronomical life. And they made it happen. So I can't tell you how grateful I am to them. And they found contractors, they found people to do work in the middle of the desert that was just exemplary. And so we have this beautiful metal-sided building out in the desert, in the Sonoran Desert, 65 or more miles west of Phoenix, out in the desert. And we have a small light dome from Phoenix that's about that high in the sky in the east. And overhead and to the south and to the west, where it all matters, it's just beautiful dark sky. It's just, it's makes you cry. It's so dark. It's beautiful. So I think that hey, Jade is here. Hey, high speed low drag. Hi, Jade. So the roof going on and off demos really nicely. You can see it, and I got that all. That's gonna be all remote controlled. So I already wrote code to run the observatory, and I'm using little microcontrollers called Arduinos to control the observatory, and so it looks like it's going to be pretty good. So you guys will have a lot to look forward to, I hope, as I do. We're going to be checking it out and enjoying that very much, and you'll be seeing sights. When you see the Dumbbell Nebula out there, I suspect it's going to be just a little bit better than this. I'm being facetious. It's going to be a lot better. And I said to some of you before, I think to everybody, there's going to be 3 piers in there. One's going to be another streamer that's going to be renting a pier for me. And the other 2 is for this telescope we're using tonight, but out there. And then there's going to be a wide-angle view telescope in there as well that we're putting in. And that's going to be for the wide-angle shots. And they'll all be available online all at once. So we'll be able to jump back and forth between systems. And that's the idea. And I didn't say this to you guys. Out in the middle of the desert, you don't have internet. So we're tapping into the landowner's, a friend of mine's, HughesNet, which is satellite internet. But that only has a 3 megabits per second upload. And for those of you that know internet speed, you know that that's really slow. But we need upload. We don't need download. For download, they have like, was it 15 or 20 or something, maybe 25, I forget. But it's really slow. But we need upload because we're sending stuff out. We're sending stuff out of the observatory. So HughesNet only has 3 megabits per second. Conversely, here we have 12 megabits per second upload. We're 4 times faster here. So how are we going to achieve that out there? You're not going to believe it. The astronomer's bane, Daryl, okay, Starlink is going to be available 74% of the time to us out there. Over the course of a day, we get out of however many hours, we get 74% of them. So we're going to be able to hook in, and we're going to actually use Starlink for our internet. And that's 40 megabits per second upload, faster than here, and 100 megabits per second download, slower than here, but we only use, we don't need download for this.
think I read recently that Starlink's doing a beta test now, and they're saying $99 a month for 50 megabits down.
Yeah, I was looking at $80 for 40 megabits up. And that all I care about is up. I don't care about down. If down doesn't exist, that's not as much of a big deal. But we just care about sending out.
Yeah.
But man, anyway, so guys, because of the clouds, we're gonna be done for tonight. I leave you here with the Dumbbell Nebula, and we will come back on the next clear night, which could be as soon as tomorrow. And there will be a point where I'm going to stop with this particular SkyTour LiveStream east as we take the telescope down and send it out west, and then put the other telescope that's behind me into the dome here, and to take up the slack. So hopefully we'll only be down for a day or two when that happens. Anyway, the last thing I wanted to mention was, because we're going to have this same telescope in the dome, in the building out west as the building here, we're going to do something pretty amazing, I think. I've never seen it before, but I'm gonna guess that no one has ever taken a picture of the moon in 3D. And that means a shot from Arizona, a shot from here in Connecticut. Binocular vision on a grand scale. And we'll be able to actually get a 3D image of the moon for the first time in history. I think that'd be pretty cool. You know, I've never seen them before, but I think that'd be pretty cool. And we'll make it so that you could see it in 3D using a variety of methodologies. And I'm quite familiar with 3D because I work with that with Douglas Trumbull all the time, where we created a 120 frame per second 4K 3D system. I just did a whole bunch of stuff with him. I got more to do, but on a movie about Nikola Tesla, all in 3D, and we filmed in 3D. We filmed this special thing that I made for them for that movie. So it's pretty cool. I think it's kind of neat, and I think that we'll be able to talk more about that once it's out. Anyway, you guys have a good night. I hope you enjoyed SkyTour LiveStream tonight. And Carol, thank you for joining me. And Daryl, thank you for joining me.
Well, thank you for inviting me. It was so great you could join too, Daryl. This was really terrific.
Yes, it was wonderful.
Thank you. I guess late's better than never.
Yeah, absolutely. And happy Halloween, everybody.
Yes, happy Halloween. And if my stories were a little bit frightening, keep in mind it's actually all true. Every bit of it. It's true.
Yeah.
Yeah.
Good night, everybody.
All right,
Good night,
guys.
everybody.
We'll see you later. You have a good night.